Good morning, everyone. I, Lovely Singh, representing A.K.S. University, and welcomes you all on the second and the last day of International Webinar on Recent Contribution of Chemical Science to Modern Society, in collaboration with Govt.Girls P.G College, Satna, with Faculty of Basic Science, A.K.S. University. Today, we are having many esteemed personalities to outshine our webinar through their presence, and we are humbled and honored that they have given their consent to grace our session for today. Before I start, as we know that we all are connected today globally because of the pandemic of COVID-19, so many researchers, many educators, eminent personalities, and engineers are connected through us. And today I would like to take this opportunity to share with you all the journey of A.K.S. University through this international platform. A.K.S. University was established in the year 2011 with the vision and able leadership of university's Pro-Chancellor, Engineer Anant Kumar Soni, whose vision has emerged to create A.K.S. University as one of the elite institutions of the nation. He believed that the higher education must have its foundation deep in national consciousness. A.K.S. University is a place where modern methods of intellectual, physical, and spiritual educations are to be fully utilized through an effort for the propagation of knowledge, where the moral improvement of students is regulated in one hand and the research work of higher order is conducted on the other hand. I consider it as a great honor and welcome to invite our visionary engineer Anant Kumar Soni sir, Pro-Chancellor A.K.S. University, for the opening and welcoming remarks on behalf of A.K.S. University. Over to Soni sir. I welcome
Thank you
all once again.
मेरी आवाज आ रही है?
Yes, sir, you are audible.
Okay. इस वेबिनार में उपस्थित डॉक्टर एम.एल. शर्मा साहब जो नेपाल से हैं, नमस्कार साहब। श्री श्याम पांडे जी, मैडम दीक्षारिया जी, डॉक्टर हर्षवर्धन सर और डिपार्टमेंट के सारे फैकल्टी मेंबर्स, गवर्नमेंट गर्ल्स कॉलेज की फैकल्टी मेंबर्स, स्टूडेंट्स जो भी इसमें से कनेक्टेड हैं थ्रू यूट्यूब और यूनिवर्सिटी के लाइव चैनल्स के थ्रू, मैं सभी को नमस्कार करता हूं। विश्वविद्यालय शुरू से ही हमेशा इस कोशिश में रहा है कि जो एक्सपर्ट्स हैं अलग अलग क्षेत्र के, उनको एक प्लेटफॉर्म पर लाया जाए। हमारी कोशिश रही है केमिस्ट्री के क्षेत्र में हम कुछ रिसर्च कर सकें, आगे उसको बढ़ा सकें, और मैं बड़ी गर्व के साथ ये बताना चाहता हूं कि हमारे विश्वविद्यालय ने कई ऐसे प्रोडक्ट्स बनाए हैं जो बड़े यूनिक हैं और जिनको हम बहुत जल्दी ही पेटेंट और करा के उसको मार्केट में उतारना चाहेंगे। मेरा वैसे बहुत ज़्यादा दखल नहीं है विश्व केमिस्ट्री में, लेकिन मेरा एक विज़न है जो मैं आपके साथ शेयर करना चाहता हूँ। यदि ये आप एक्सपर्ट्स लोग इस पे कुछ काम कर सकें तो बहुत बढ़िया होगा देश के लिए और पूरी वर्ल्ड के लिए। जैसे कि कल सोलर पैनल पे कुछ बात हो रही थी, सोलर सिस्टम का जो बेसिक फंडामेंटल है वो है सूर्य की रोशनी पर है कि जब वो सूर्य की रोशनी पड़ती है तब उसमें से हम इलेक्ट्रॉन का मूवमेंट होता है और इलेक्ट्रिसिटी प्रोड्यूस होती है। यदि हम कुछ ऐसी व्यवस्था बना सकें, कुछ ऐसा केमिकल ढूंढ सकें या कुछ ऐसा मटेरियल कॉम्बिनेशंस ऑफ केमिकल्स के थ्रू बना सकें या ढूंढ सकें जिसमें कि रात के समय में हम इलेक्ट्रॉन का मूवमेंट कर सकें, सनलाइट दिन में हो और एक ऐसा पैनल हो जिसमें कि या तो टेम्परेचर वेरिएशन से हो कि रात के समय में लाइट पैदा हो सके। ये समझिए कि वर्ल्ड की सारी समस्याओं का समाधान हो सकता है। इलेक्ट्रिसिटी बिल्कुल पॉल्यूशन फ्री और 24 आवर अवेलेबल इलेक्ट्रिसिटी बन सकती है, और ये सब केमिस्ट्री और फिजिक्स के लोग मिलकर के कर सकते हैं। मेरा एक छोटा सा सबमिशन है आप सबको कि यदि आप इस तरफ ध्यान दें, इस तरफ ऐसा करें, तो शायद विश्व की एक बड़ी समस्या हल हो सकती है। मैं लगातार इस वेबिनार में जुड़ा रहूंगा, यूट्यूब के माध्यम से सुनता रहूंगा, और मैं सबका पुनः स्वागत करता हूं, देश विदेश से जो लोग जुड़े हुए हैं। धन्यवाद। ओवर टू रवली मैम।
Thank you so much, sir. We are always been grateful to you for your words of wisdom. And now, the organization without our guide and mentor for this webinar, the conduction could never have been possible without the guidance of Professor Harshvardhan Srivastava, sir. Presently, he is holding the position of Pro Vice Chancellor at A.K.S. University, and I deem it as a proud privilege and honor to invite Professor Harshvardhan, sir, for the welcoming remarks on behalf of A.K.S. University. Over to Dr.
Hello.
Harshvardhan, sir.
Am I audible, madam?
Right, sir. You are perfectly audible,
Okay,
sir.
thank you.
Thank you, sir.
Okay, I do appreciate the initiative of Chemistry Department of Chemistry of A.K.S. University. Dr. Yadav and his own entire team, including the Physics Department and our Dean. I have a very great pleasure that all the eminent faculties of chemistry department of the Asian countries, including Nepal and in the country itself, all the eminent invitees and the government girls college Satna, the principal Dr. Richardia, her team. I welcome the idea of recent trends in chemical science, and it is very important with the advent of industrialization. The chemical science and physics both have taken lead in the development of industrialization and to fulfill the need of the society. And it is very important issue how the society should be now benefited with the facilitation of several innovations, research, etc. Without research and innovation, the day-to-day life cannot be more smoother. So in that pretext, I welcome and I hope the webinar on such an important issue shall be useful for our students by and large, and researchers should be also benefit. I, on behalf of A.K.S. University again, wish that all outcomes shall come broadly and before the society, the government and researchers. The chemical reactions and various innovations shall facilitate our life more beneficial. And now thank you very much for inviting me on this webinar. Since I am not at Satna, I am really sorry not to be fully benefited, but I will try to understand what outcome has come after this webinar is over. Thank you very much. Okay.
Thank you so much, sir. It's always been grateful to have your words of wisdom and to enlighten our path to conduct such programs in future too. Now, moving ahead for the technical session, I would like to invite and heartily welcome our first plenary speaker of this session, Professor M.L. Sharma. Professor M.L. Sharma has done his PhD in chemistry on oxovanadium complexes with multidendate ligands from Gorakhpur University, Uttar Pradesh. At present, he is working as professor at Central Department of Chemistry, Tribhuvan University, Nepal. He is also the member of Chemistry Subject Standing Committee, Institute of Science and Technology at Tribhuvan University, Nepal. I warmly welcome our first plenary speaker, Dr. M.L. Sharma sir, for this session. Over to Dr. M.L. Sharma. I request Dr. M.L. Sharma to please unmute his microphone.
Good morning, madam. Good morning. Is my presentation is there in your screen? Yes.
So, still it is not visible. Earlier it was visible, right now it is not visible.
Okay.
So just minimize your screen, then it will be okay. So your screen is visible to all now.
Is it visible now?
Yes, sir. Yes, sir. Please go ahead.
Oh, okay.
Perfectly all right.
Okay. Thank you very much, madam.
Thank you, sir.
And all the dignitaries in this morning session, our respected founder, engineer Soni sir, Professor Srivastava sir, who just delivered their lectures, and all the members of the organizing committee, and my elder brother, Professor S.S. Pandey, who was senior to me, and he is joining from the Japan. I extend my warm greetings from Kathmandu, Nepal. Now, today's my lecture is on contribution of Ayurveda to modern society, need to address from modern viewpoint. Why I have chosen this topic is this is a very ancient type of traditional medicine, which is directly related with the chemistry. In the modern chemistry, we are just looking forward the modern, so many modern chemistry, synthetic drugs, and everything. But this part, which is very ancient type of medicine, it is not being approached from the modern viewpoints, or modern technologies are not been able to reach to this very important side of our traditional medicine. We know Ayurveda is science of life, which deals with the use of the herbs and herbal preparations for the treatment of various ailments. Now, today, what I'm going to present is about the Ayurvedic bhasmas. We all are very familiar. These bhasmas are all the oxides of the metallic oxides, or all the mineral oxides, or whatever the oxides. The burnt things are these are the oxides, which are termed as bhasmas in Ayurvedic medicines. These bhasmas are unique Ayurvedic herbometallic preparations useful in various ailments. Quality of bhasma depends upon quality of starting materials, processing ingredients, meticulous titration, and having heating cycles. And to strengthen the quality of Ayurvedic product, standardization of bhasma and other Ayurvedic drugs are very, very essential. So in this regard, we are trying to do little bit in our laboratory at Central Department of Chemistry in Kathmandu. It is said that incomplete incineration would result in metal ion impurities, which lead to the adverse effect, and they cause the toxicity to the human being. Because many many Ayurvedic medicines are sold in the market, and we are very much fascinated that this increases the that strength or the that strength. That's why we have to look into all this, whether these drugs have the side effects or not. That's why it is very, very important to do some research work in this regard. Now I'm going to do, this is an introduction. The Ayurveda, it is a science of life. In our Rig Vedas and all, it is called the mother of healing. Ayurveda is a life knowledge, and Vedas in Ayurveda, Rig Veda, Sama Veda, Yajur Veda, and Atharva Veda. And we talk about our Kabiras, the Ayurvedic doctors. They quite often they pronounce the three dosas, three demerits. This is Vata, Pitta, and Kapha. Focuses on harmonizing the body with the nature through diet, herbal remedies, yoga, meditation, and lifestyle. All these ingredients, all these type of things are associated with the Ayurveda. That's why it is a very, very important branch of the science, which is brought from the our ancient medicine system. So the fundamental, what is about the Ayurveda? One should know Ayurveda means the life of science. It is directly related with the medicine, Vajikaran, Jara Chikitsa, and Kaya Chikitsa, Salakya, Agatantra, Shalya, Bala Chikitsa, and Bhut Vidya. All these are the different types of the Vidyas which are described in the Ayurveda. I'm just talking about the introduction, and I will, right from this point, I will go to the Ayurvedic Bhasmas, a little bit about this. Now, what we are doing is I'm doing in my laboratory about the taking the three. I'm preparing the three bhasmas, three oxides of one is the Lohva bhasma. This is the bhasma of iron. Second one is the Yasada bhasma of zinc, and third one is the Tamra bhasma. This is quite familiar with this the copper bhasma or copper oxide. Bhasmas are herbometallic acids and medicinal treatment in 7th century, and low bhasma is an iron nanoparticle used to treat the many type of ailments. Bhasmas are first time introduced in Ayurveda textbooks in Rasa Shastra. In the different, when I went through the so many universities sites in particularly in India, there are the Rasa Shastra department also, and the metal compounds are the ferric oxide and the ferroso-ferric oxide, and ferroso-ferric oxide is the mixture of the ferric oxide and the ferrous oxide. These oxides are taken in our body, and how they affect, that's a different thing. That makes us very that arise very interest in our group. Bhasmas are the drugs of the plant, animal, and the mineral origin, and lower bhasma is an Ayurvedic medicine used in the treatment of the different diseases like anemia. Bhasmas are, and in other words, bhasmas are the nanomedicine, which is the relevance of the nanotechnology. And we all know that the iron is the essential element for blood production, present in the red blood corpuscles cells as a hemoglobin, present in the muscle cells, in the myoglobin. Iron is important component of certain protein like ferritin, essential for respiration and energy metabolism. Next one is the first one. These are the herbometallic Ayurvedic. This is the intricate system and quality Ayurvedic medicines. So far, zinc oxide. These are the nanoparticles. Ayurveda Prakash, and 40. This is the very. It is the 14th century. This was developed in the 14th century. Very old. This is the system, and the zinc oxide is taken as a rusk of sattva to treat the diabetes. And in the Charak Samhita and the reduction of the particle size, Ayurveda classified in the Vaidika Samhita, post Samhita periods, and it's a different. And these are the books we followed for the preparation of the bhasmas. In the 15th century, it was derived in the Yasada bhasma. It is called the Madanpal Nighantu, and originally it was in the Hindi, and this time it is also found in the Nepali also. And are translated into Nepali, and practical aspects of the Yasad Bhasma. This is quite derived in the Rasa Tarangini, that Shastra. And in the 12th century, this Sargadhara Samhita, it tells about the dose, how to take all these medicines. You know, this is the Yasada Bhasma. Yasad means zinc. Yasada Bhasma it is used as the anti-arthritic, antipyretic, antacid, anti-inflammatory. And thereafter, the Yasad Bhasma as the skin diseases, anemia, osteoporosis, and eye disease also. Now, what's the? We are just going to talk about rationale of the studying about these bhasmas. And these are used, these Ayurvedic bhasmas, these are used to treat the diabetes, rheumatic disease, cancer, stomach ailment, liver disease, and urinary disorders. What are the risks? Risks is there are different type of risks. Mode of consumption, it varies from doctor to doctor, one kaviraj to another kaviraj, and storage, how to store all these type of bhasmas or drugs, it is not well defined, and improper prescription, it also varies from place to place, countries to countries. Actually, these type of practices are quite popular in our South Asian countries, mostly in India, Nepal, little bit in the Bangladesh and the Sri Lanka also, and we are the very important the consumers of these Ayurvedic drugs, particularly the bhasmas. That's why these are the non-standard preparation. How they prepared these bhasmas and they are selling in the market is there. We do not find any standard type of preparation in today's in the market. Now, research questions and our priority. That's a, since this is a from the modern approach, we find that this should be the very important uh, thing to do the research to work on. That's why what is the physical, chemical, and microscopic structure of the given plasma? This is a very important question, I guess. And is it a kind of nanomedicine with respect to its structure? What is the real chemical composition? We don't know. How do bhasmas differ with respect to their microbiological effect on the human body? Will the bhasmas show significant cytotoxic effect only towards the cancerous cells? How will the normal cell lines respond? Can a correlation be established between the structure and properties of the bhasmas? These were the very important thing. And priority, they made the sustainable development goal set by the UN, and protection of the indigenous knowledge. This is the very, very important, because our indigenous knowledge, or you say the traditional knowledge, it is being disappeared. It is not being transferred from one generation to another generation. This is the very challenging for us actually in the Indian continent. This is because this type of medicinal system that in China, they are preserving their indigenous knowledge, and the Chinese medicines are also very popular in China. But in our continent, in our South Asian continent, where the major part is the India, and in our region, it is not being properly protected. Employment, if it develops the employment by industrial development, we can do this, and it must be related with the science and technology or the nanoscience. In bhasmas, in Sanskrit, the pure metals, this is the bhasmas are obtained by the oxidation of the mercury. This is called the parad or kajali. Arsenic, hartal monocyla. We know that the arsenic is this is the dangerous chemical we say, but it is quite frequently this is used in the Ayurveda. And lead, naga sisaka, and gold, swarna. And minerals and animal products, these are the mica,
Hello. Sorry to interrupt you, sir. You are not audible to us. Sharma, sir, you are not audible. We request Sharma, sir, to please rejoin the meeting. Dr. ML Sharma sir is connecting to us shortly. Please have patience.
Hello.
Hello.
Hello, madam. Is this
Yes,
okay?
yes, sir. You are
Oh,
audible now.
okay. But it is very difficult to
No
go by
issue,
the
sir. We are
slides
trying
because
to open your slides.
I've already sent my presentation slide to Sailendra Yadavji's mail.
Okay, sir. No issue. So we are trying to open your slides from here itself. Once it will be
Oh,
shown, you
okay.
just start your lecture thereafter. Okay, sir.
Oh, okay. Shall I wait for a while?
Yes, sir. For just for
Okay.
another 2 minutes, we are
Okay.
trying to connect it with you. Dr. M.L. Sharma is having very interesting topic. He is connecting science to Ayurveda. And in other words, I can say he's connecting Ayurveda to science. Both are integral part of each other. And his topic seems to be very interesting. So it's a wonderful choice of your topic for today's session and to make this session a very interesting one since it is the first lecture of the session. We are just trying to connect with the PowerPoint presentation for this session. Another 2 minutes, sir. So we are able to connect with the
Okay. Thank you,
PowerPoint
ma'am.
presentation
Next.
of Sharma,
Yes.
sir.
Yes.
Yeah. So
Please start
from this
here
slide, okay,
from
okay,
this
sir.
point.
Okay, sir.
Okay.
Please
Shall
continue,
I
sir.
start?
Yes, sir. Please continue.
Oh, okay. Okay. Thank you,
So
madam.
please let us know when you have to change the slide. You just say next. We will switch on to the next slide.
Okay. Okay. Thank you, ma'am.
Okay, sir. Please
Thank
continue.
you. And Bhasma powder, these Bhasmas are the powder obtained by the calcination, and calcination is simply the oxidation process. That's why I'm giving here the Ayurvedic term and the material and the English term. And to learn all these things at the same time, I'm not a Sanskrit student and I don't know this, and I'm just trying to have some these terms only. That's why it needs a lot of this discussion and inputs. And source of the metal is the shodhana. It is called in the English the concentration. And purified raw material, this is the marana. Marana is the calcination. And this when the bhasmas were prepared, they were passed through the XRD diffraction technique, and we found this that these are in the nano range. Okay, and it is repeated until desired product is obtained. Next, please. And I try to do the Yasada Bhasma, Loha Bhasma, and Tamra Bhasma. Next, please. This is the slide for the how we had proceeded in our laboratory. This is the very simple thing. Okay, next, please. And materials and methodology. Yes, another click. And purification. Yes, this the raw material was heated, melt, and poured in milk, and thereafter, in most of the cases, it happens. Thereafter, heating and roasting is done, and with the Azardica indica, this is the neem branch till the powder is obtained as it was written in all the three books I have already shown. And the levication is the mixing of these bhasmas with the various juices, sometimes with the lemon juices, sometimes with the aloe vera juices, or there are so many juices. And the incineration, this is the heating. A sample was heated by traditional method of heating with the cow dung and using electric
muffle furnace. In modern day, we do the with the help of the muffle furnace. These are the materials and methodology we had followed after purification with zinc metal, after heating and roasting, after navigation, after passing through so many times treating with a different type of juice, incineration with the traditional heating, and incineration with the electrical muffle furnace. These are the product we have prepared, and these are the some of the results and discussion that the organ we studied the organoleptic character, physico-chemical analysis, and classical parameters. Next is the since these are the FTIR of Yasada Bhasma prepared by the incineration with the traditional method of heating, and the next one is the electrical muffle furnace of heating. Electrical muffle furnace. Next, please. Yes, this is the slide. And we get there are the different when we do the FTIR spectra, there are some of the organic compounds. This is the OH group, CH3 group, NH, and all these type of groups are obtained because these were already treated with the organic things. And these are the XRD. Next, please. Yes, this is the XRD analysis. XRD spectra of the Yasat Bhasma prepared by incineration with the traditional. We had followed the traditional technique, and we followed the electrical muffle furnace heating. And these were correlated with the JCPS data, standard data. Next, please. And these are the crystallite size of Yasat Bhasma prepared with incineration, traditional method of heating, electrical muffle furnace of heating, and these are the samples. And average particle size found is the 191 nanometer and 167 nanometer. And these are the EDX, energy dispersive X-ray spectroscopy, and we found that in case of the Yasada Bhasma, zinc naturally this is in the almost about 95% or something like that, and thereafter we found the potassium and the iron also in both the cases. Uh, in the sample which were carried by the which were heated or incinerated in the electrical muffle furnace, there was no iron, but there was potassium, and there the zinc is naturally there is present. And this is the results. And when we do the results and discussion, when we discuss about this microbial analysis, this were obtained by the disk diffusion method, and staphylococcus aureus and E. coli and tetracycline and ampicillin were taken as, and we found overall we found that these things, these bhasmas do the very good. Next, please. Next slide. Next slide. Okay, next slide. Yes, in this way, we have performed these experiments, and these experiments are very, very exciting. We found in our laboratory, and we guess there's this type of things, and we are making one paper. It is almost ready, and we are just very soon we are going to publish this. Next, please. This is the experimental part of the Tamra Bhasma. I just wanted to show you the picture of this. The very first, this the copper pieces. They are heated and the purified with the purified mercury, and this was treated with the mercury. It is a very long procedure, and purified with the sulfur and the mixture of sulfur and titration above mixture, and finally it is found that the kajali was prepared. And there is a very different type of things. It is very difficult to explain why in our traditional these books these were treated with the mercury parad, or sometimes with the sulfur, and sometimes with so many things. We had just prepared following those books, because these books are very encyclopedia for the preparation of the Ayurvedic bhasmas, and the bhasmas sold in the market are prepared on the basis of those books, which I have already shown you. Rastarangini. Next, please. Here you see the physical properties, and we studied all these so many properties. And next one, next slide, please. You see, this is the web FTI Kachali, this is the Tamra Bhasma, and there is the RCOOR. This group is also present. PH, CA, there are so many groups are present. From this FTIR spectra, we came to know this conclusion that in the name of the Tamra Bhasma or Loha Bhasma or Yasada Bhasma, we are consuming so many organic compounds at the same time. And we are also not very much aware that those metals used were well incinerated or not. That's why at the same time while taking these bhasmas, we are having the metal particles. Next is this the XRD picture of the Tamra and from this the sharpest peak is the XRD graph is the 2 theta value is 33.35 degree represent the copper sulfide having orthorhombic shape. Copper sulfide is also there. At the same time we are having the copper sulfide. Similarly, this Cu2s cuprosulfide, Cu2S7, these are so many things are produced and crystallinity is the 38.30%. And the average size of the nanoparticles obtained were from the 17.38 nanometer. Now this is about the EDX diagram of the Tamra Bhasma. You see copper, sulfur, potassium, silicon, mercury, zinc, calcium, terbium, bromine, iron, chromium, lead and other elements were also found in our Tamra Bhasma. And this Tamra Bhasma is used for the cure of so many diseases. That's why it is very needed that all these drugs must be standardized from the new point of view or modern point of view with the different tools of different modern tools and results and discussion. But this since there are so many metals, so many elements are present, thereafter we can say that their effect, the antimicrobial activities are very good. I don't know whether these are because of the Tamra Bhasma, pure Tamra Bhasma or other elements present in it. And these are also the other things. And the results and discussion, we did all these type of Tamra Bhasma, photographs showing the minimum inhibitory concentration of the Tamra Bhasma against E. coli, Staphylococcus aureus, Bacillus subtilis, Enterococcus faecalis. And this is another table, antimicrobial test carried for the Tamra Bhasma. Please, next please. Next, again next. And yes, yes. This is the photographs showing minimum inhibitory concentration of Tamra Bhasma against E. coli, Staphylococcus, Bacillus subtilis, and Enterococcus faecalis. Next, please. Next is this Bacillus subtilis. We can see that the results and discussion. And from this, we have taken the different reference culture for the gram positive and gram negative bacteria, and these are the results. We are having these results. Next, please. This is the experimental, the way we performed the Loha Bhasma. Iron fillings, these are the iron fillings, iron turnings, and these were heated in the electrical muffle furnace. These were quenched directly into the, sometimes with milk, sometimes with the water, and these are filtered. And this way, this is the product which you are seeing on the normally purified iron turnings on the dish, on the plate. And this is one of my students, he is working on this Loha Bhasma. And special next please. Next slide, please. Yes. Yes. Okay. And we tried the preliminary test of the Loha Bhasma, order of floatability, fineness, luster, fume, and loss of drying, total S value we calculated, and all these type of things. And these the FTIR diagram for the Loha Bhasma. In this diagram also you can see that the carbon and hydrogen bonding is there, OH is also there, and CO, CC, all these type of things are there because these were before, during the preparation of the Loha Bhasma, we name it as the Loha Bhasma or oxide of the Bhasma, but this is a kind of mixture of the so many organic compounds. And this is about the XRD diagram for the Loha Bhasma, and the XRD diagram, the particle size was calculated by using the device error formula. and you can see that the particle size of the lower Bhasma found to be 57.23 nanometer. Next is EDX, the data, lower Bhasma, iron, potassium, chlorine, calcium, and little amount of magnesium is also there. That's why this is the EDX spectra carried here. Next is this, all this show the very good this microbial activities, antimicrobial activities. Next, please. Next, please. I've shown similar type of these things. And acknowledgement. Before acknowledging you, I would like to say something that this is a very new step towards new step we are making for the working on the field of the Ayurvedic medicines, because in our medicinal system we have in our continent, in Indian continent, there are three types of medicinal system. One is the allopathic, we all almost trust, and thereafter the Ayurvedic, Unani, and homeopathic medicines. Which one we should follow is quite ambiguous. That's why we cannot ignore the Ayurvedic medicines, but the significant population of this continent, they believe in the Ayurvedic drugs, and we say that the Ayurvedic drugs, they do not have any side effects. We say at the same time, but we follow when they don't. We say that they don't have side effects, but we are not blindly. We cannot blindly believe on these facts, because we are trying to do this, all this. That's why what I would like to say, the scientists in India and Nepal and all, because that we must give we must consider about the Ayurvedic medicines to do something on it, and the healing, which is the result of the 1,000 years of observation and extensive research of clinical practitioners. That's why this must get good attention. Medicines are derived from the all source of nature. That's why nature itself is very good. That's why we all are here to do this. A lot of people look for a fast track to success, but we must move on this. That's why we all must stand together. If not here, where we can do this? If not now, when? If not we, who? That's why let us stand to do all this, to standardize the Ayurvedic drugs. This is my little opinion about this, because this is the untouched or the virgin type of field from the modern point of view, chemical point of view. That's why at the last moment, I would like to acknowledge the organizing committee members for international webinar on recent contributions of chemical science to modern society, and Govt.Girls P.G. College, Satna, Madhya Pradesh, India, Faculty of Basic Science, A.K.S. University, Satna, MP, India, and Dr. Neelam Richaria and Dr. Sailendra Yadavji for inviting me to join the webinar. And these are my students, Purushottam Mandal, Gopinand Karna, and Rajesh Paudel. They are doing on the different bhasmas, and they are having some good results, I guess. And thank you very much for your patience, and little bit for the inconvenience caused by the cut electricity. Yes. Thank you very much for having me in this international webinar with dignitaries. Thank you, lovely ma'am, and thank you all.
Thank you so much, sir. It was a wonderful session, and which add glory to our program. And it was wonderful listening to you, your deep knowledge and your profound research work put a lot of interest to this session. We are very much grateful that you have given your precious time for this session. Thank you once again, sir. We are humbled, obliged to Dr. M.L. Sharma for his presentation. Thank you so much, sir.
It's my pleasure. Thank you, ma'am.
Thank you, sir. So, many eminent personalities have been connected to us. I would like to welcome once again Dr. Shamis Pandey, Professor at Kyushu Institute of Technology, Japan. I welcome Dr. Amrish Singh. I also welcome Dr. Indrajit Sinha, sir. So taking this session further, I would like to invite and welcome Dr. Amrish Singh, working as professor at School of Materials Science and Engineering, Southwest Petroleum University, China. Our next plenary speaker is Dr. Amrish Singh. He is having a very good profile. Earlier, he was postdoctoral research fellow at School of Materials Science and Engineering, Southwest Petroleum University at China. In 2016, he has got the President's Award for Outstanding Postdoctoral Work. His research interests are development and testing of various natural compounds at corrosion inhibitors, corrosion prevention techniques and phenomena, computational chemistry, green chemistry, polymers, nanomaterials, composites, material science and engineering, alloys, petroleum engineering, electrochemical measurements, and synthesis of compounds. I would like to invite and warmly welcome Dr. Amrish Singh for today's session, and his topic is New and Traditions Electrochemical Techniques Used in Corrosion and Development of Some Biopolymers. Over to Dr. Amrish Singh.
Thank you for the nice introduction, ma'am. Good morning,
Thanks.
everyone. And I must like to congratulate Dr. Sharma sir for his night lecture beforehand. And I will be presenting my work on corrosion, what we are doing in China. Uh, I hope it is visible to all.
Yes, sir.
Okay, so I will be talking about some electrochemical techniques, what we are using to monitor corrosion, and some biopolymers which we have developed for our international collaborators in Saudi Arabia. So I will take it over from here. So our university is located in Chengdu, China, which is famous for pandas and the food hot pot. We have a very good research facilities. We have some pilot divisions. We have the CNPC pilot divisions. We also have the state key laboratories. Then coming on to corrosion. Corrosion is something that is multidisciplinary as well as interdisciplinary. We see it every day in our lifestyle from morning to evening. Or in short, if I would like to say, wherever there is metal, there will be some type of corrosion. There are different forms, and these different forms, sometimes they do cause different type of accidents, especially in oil transportation, petroleum industries, etc. Not only there, but mostly in pipelines, in boilers, where they are stored, these type of things happen. And also in weapons, after some time, they get corroded, no matter what materials you're using. Aviation industry also suffers huge loss due to corrosion. So how do we measure it? There are many techniques. So I will just talk about some selective and new techniques only, because most of the time we don't have these option to study about the recent techniques due to lack of machines or something. So I will mostly focus on these things. First, the electrochemical workstations. Uh, like in our lab, we are having 4 to 5 workstations of different companies. We are having Autolab, we are having Gamry, we are having CHI, we also have Parstat, Princeton. So we are having an access to almost all kind of good electrochemical workstations. So different like Parstat 2273, Autolab as well as Gamry. Usually when we are doing the corrosion test, we are using the 3 layer assembly, where we are having the working electrode, the reference electrode, as well as the auxiliary electrode. The first preferable electrochemical work what we start is the open circuit potential, where we can see this. This is the real-time picture of open circuit potential, where we are having this straight line. When we are having this straight line, it indicates that whatever immersion time we are using, either it is 15 minutes or 30 minutes, our potential is quite stable. And whatever results we will get, it will be an optimum result. So this is what we have done with our inhibitors. So we can clearly see 2 different pictures, and we can see the time. Like it has been done for 500 seconds. So in all the cases, we have a quite linear potential here. Means The in these cases we use 30 minutes immersion time. So for 30 minutes, these inhibitors were quite stable and the potential was also very stable. Some different inhibitors, but also the result was the same, quite linear potential in all the
Sorry to
cases.
interrupt you, sir. Dr. Amrish Singh, your slides are not getting changed.
Huh? Not getting changed.
Yes, sir. We are on the first slide only.
Oh,
Now it is okay, sir. Thank you.
now okay.
Yes, sir. Now it's perfectly all right.
Okay. So as I was talking about open circuit potential, we are having this linear in all cases. That is an indication that our system has attained a stable potential. Then usually it is having the double layer. So if we talk about a simple Randall cell, so it is having three layers. We are having the double layer capacitance, then we are having the electron transfer resistance, and another thing what we are having is uncompensated resistance. So this is what is a Nyquist plot, what we get from the electrochemistry experiment. Here we are having the high frequency region as well as the low frequency region. Then another type of graph what we are getting is the Bode plot and the phase angle plot. So as we are talking about EIS, so this is the formula that we are using to calculate our results. Now this is the real-time picture from Gamry. So when we run a particular test, we get the first picture of Nyquist plot, the second picture that is having the Bode plot as well as the phase angle plot. And this is the circuit that we can modify depending on our test conditions. Then modeling. One simple model cannot fit all the experiments. So there has to be different models. So we use these components to modify our models. Either we use resistors, we use Warburg impedance, we use the constant phase element, we use double layer capacitance, or we use inductance into the circuit. Apart from that, after having these different kind of results, as I have shown here, this is 81 inhibitor, 82 and 83. So all different type of results, and depending on these results, we have different type of circuits also. So this is very important when we are doing this EIS studies, the circuits. Otherwise, the result won't come. So after these circuits, we have this table from those circuits when we feed the data. And for this particular table, 81 is showing the highest inhibition efficiency, that is around 92%. NaCl, 3.5% NaCl. So here it is an inductive loop into the lower frequency region here. So here also you can see a loop. So that is why in this circuit, you see this loop is being added. Inductance is being added for this loop. And this is the value of this loop. So for blank, we are not having the loop. So we are not having the value of inductance. For others, we are having some values for this inductance. Some more examples for BZ1 and BZ2, and depending on this, the circuit. So this is for NAT steel in 15% HCl. The previous slide was for NaCl solution. So in this case, BZ1 is showing 95% inhibition efficiency for NAT steel in 15% HCl. Likewise, we are having the Bode plot here and the phase angle plot. So from Bode plot, we can have this slope value. And by this slope value, we can determine that our inhibition efficiency is going good. Likewise, with these peaks, this is the blank with the lower peak around 40 degrees, and this is the peak of inhibitors around 70 to 75. So that means when it is going close to 90, that means the inhibition efficiency is increasing. So here also we can see that these are the slope values tending towards 1 and the peak values which is tending towards 90 degrees. Then another technique is linear polarization resistance. Now another very good technique, and it takes very little time, have done in Gamri workstation. So this is the real-time study what is being done, and we take this, we select these 2 points, 1 point here, 1 point here, for the polarization resistance. And with the help of this polarization resistance, we calculate the inhibition efficiency. These are our examples, what we have done with our inhibitors. So here you can see the different changes that is pretty much eminent from the graph. And with this, we calculate that certain concentration of this inhibitor is performing better, or what is the inhibition efficiency. Another technique or very common technique is tuffle polarization, where we use this anodic and cathodic slopes, the extrapolation of these slopes to find the I core and the E core values. So tuffle polarization is plotted either vertically like this or horizontally. Both, it is just to make it look better. No changes into the experimental results. But here also we can see that there is a certain shift towards anodic direction or the shift towards cathodic direction. In these cases, the shift is not too much, so these all inhibitors are mixed kind of inhibitors. If the shift is mostly towards anodic, that is in the case of cathodic inhibitors, and if the shift is towards cathodic direction, then it is the case of anodic inhibitors. Values 81 here also perform better with 90% inhibition efficiency, and we have these E core values and I core values. So as I was talking that we can plot it either vertically or horizontally like this. Both are the same thing, just different way of representations. So here we have done some tuffle polarization for plant extracts as well as for some synthesized compounds, and we are having inhibition efficiencies likewise. So the maximum in plant extract was for CC. CC is Coptex chinensis, and for synthesized compounds it was maximum for TF, thiourea formaldehyde. Now, another good and very good technique what we are using nowadays for our petroleum partners is EFM. Before we used to use electrochemical noise, now more we are using the electrochemical frequency modulation. Why we are using this? Because this is giving the results instantly. In just 1 minute, you can have your result. To get an idea what work you are doing, what environment you are taking, how it will perform for longer time. So here we are usually using two frequencies, 2 and 5, and it has the casualty factors of 2 and 3. And all the test results are based on these casualty factors. Okay, so for casualty factors, if you want to determine theoretically, you can use the formula, and you can determine theoretically also, both 2 and 3. Now, Professor Rauf and his team, they proposed casualty factor 4 and 6 also. But experimentally, it is not possible because all the current electrochemical workstations, they are equipped only with casualty factor 2 and 3. So even if you want to do for casualty factor 4 and 6, not possible experimentally till now. Then this is the output what we are getting. So here you can see only 60 seconds and you can get the corrosion current density. And from this corrosion current density, you can calculate the efficiency. Either you are using some type of coatings or you're using some type of inhibitors, you can get instant results. Also, we have the intermodulation frequency spectra. So using these two spectra, we can have our output. That is like this. So here we have the I core values, we have our anodic and cathodic slopes, then we have the casualty factors of 2 and 3. As I have said previously, these two casualty factors are very important, and if you see the values, they are very close to 2. Likewise, for casualty factor 3, the values are close to 3. That means the experiment or the output what we are getting is okay. If the value is varying too much from 2 or 3, that means the experiment is not going good. So in this particular case also, 81 performed better with 93% efficiency. Now, always there are some questions from reviewers, from persons in conferences, that most of the time we are using this amplitude of 10. Why we are not using 20, 40, 60, 80? Why not? So for that we have run many experiments, and what we are getting when we are doing it for 2 and 5, 0.2 hertz, zero point 0.5 hertz, zero point 0.2, zero point 0.5. So when we are doing these different things, what we are seeing is at 10, the value is almost constant, not much change even if the frequency is changing. So for electrochemical experiment, 10 tends to be a optimum amplitude, which can give better results. While in other cases, you see the variation is too much in all other cases. So this was the answer that we tend to find out for everyone who are working in this field. Apart from that, this is the advanced version of electrochemical frequency modulation, or this is another technique that has trend in it. Before we saw electrochemical frequency modulation, now this is electrochemical frequency modulation trend. Here we are having two different outputs together. I'm not sure whether it is pretty much clear. Sorry for that, because I think the graph is quite low. So here we are having corrosion rate as well as corrosion current density together in this one graph in all the cases. So we are having two outputs in one graph. And again, this is very helpful for industries as the time is not limited. You can run it for weeks, you can run it for months, no problem. Apart from that, I would like to talk about some microelectrochemical techniques or localized techniques. For this, usually SECM workstation is used, or this microelectrochemical workstation. So we are having this PASTET station from the Princeton, the best one. And usually we are doing PSC, that is probe approach curve, SECM, that is scanning electrochemical microscopy, SKP, scanning Kelvin probe, SVET is scanning vibrating electrode, and LEIS, that is localized electrochemical impedance spectroscopy. We are using this VOSA scan software for all kind of analysis of all the tests done onto this instrument. First is probe approach curve. So this is how the probe approach curve looks like. Now this is very difficult work to do because it requires a lot of concentration, and since the probe is of nanomillimeter, most of the time it gets broken. If it is touching the metal too much, it will break. So one has to practice a lot for uh, doing this experiment on this kind of instrument. Even we are using the cameras, still the tip gets broken. So here we are having two type of graphs. One is when it is going towards down, another is when it is going towards up. So this is because of two different type of surfaces. One when the surface is conductive, and another one when the surface is inductive. Means when on the surface there is no inhibitors or no coating, it is conductive, so higher current. And when there is a coating of inhibitor or some type of coating, it is inductive or insulating. Second is electrochemical scanning electrochemical microscopy, or SECM as it is commonly called. So this is the graph what we are plotting using origin. We also can have the different graphs from different softwares, and these are the current values. So for blank, the current values are always higher in comparison to the inhibitors. So for 81, the current were much lower, suggesting that the surface was addition of inhibitors, whether the anodic potential was increasing or not. Then scanning vibrating electrode, it is little expensive in comparison to other techniques because usually it is being run for longer time and we have to pay a lot of money each hour for running this type of test. So here if we see this is for NaCl solution, we see that as soon as the metal was into solution, corrosion started in presence of carbon dioxide. It got increasing, and after 10 hours there was much corrosion onto the surface. While when we are using the inhibitors, in comparison to the blank, it was less corroded even after 10 hours. Coming on to our recent work, what we are doing, that is biopolymers. So we developed many biopolymers using different synthesis schemes and published many papers. and some patent has also been applied onto this. So this was our first polymer from where we started, and it has already been published, I think, in scientific reports. So this was this polymeric reagent which we synthesized using aniline, formaldehyde, piperazine, and this was the final component. Second one was we used AMPS, and this was when we are using the guar gum. And this work has been highly appreciated in many conferences, and lots of paper has been published using this biopolymer. Last one is, which this work is still not published, and we are still working on it because as you can see, it is quite complicated. Because for the first time, we have used some nanoparticles also into this to enhance the efficiency. So what difficulty we are facing is when we are doing our theoretical work using Materials Studio and Gaussian, still we are not able to find the module, or we are not able to develop the perfect function how to analyze this using the quantum chemical softwares also. Practically we are having the result, but we want to support it using the softwares also. So that is one thing what we are lagging behind for this particular work, but still a very good thing. So thank you all the committee members for including my presentation. Especially I would like to acknowledge all my international collaborators, students, staff who are working day and night. Financial assistance by Sichuan Thousand Talent Fund, NSFC China, also our university's open funds. Our current team who are working together, and none the least, Dr. Shailendra Yadav, who was consistently following me for quite some time, although I was not able to make this presentation because I'm somewhere outside. But because of him, I have to do this. So thank you, Dr. Shailendra. Thank you all.
Thank you so much, sir. And on behalf of Shailendra, sir, I'm very much thankful that you have given your precious time for this session. Thank you once again. Your lecture was actually full of zeal and very valuable knowledge, which reflects through your lecture. And I'm actually having your CV holding in my hand right now, and I'm amazed to see your deep research knowledge and your long list of achievements, which is allocated to you at such a young age. So thank you so much, sir, for your intellectual words, and it was wonderful to be here with you. Thank you so much once again, sir. Our next distinguished speaker to honor us with his presence is Dr. Indrajit Sinha. I heartily welcome and invite our next distinguished speaker, Dr. Indrajit Sinha. He's working as Associate Professor at the Department of Chemistry, IIT BHU, Varanasi. And today, his topic is Computational and Experimental Studies on Interfacial Phenomena. Once again, I welcome Dr. Indrajit Sinha, sir. Over to Dr. Sinha.
Good afternoon to everybody. And can you hear me?
Yes, sir.
Okay. So good afternoon to everybody. And I begin by, of course, thanking the organizers for inviting me to this session to share our research, an overview of our research, recent research in the area of interfacial phenomena. So I will just present my screen.
I request Dr. Amrish Singh to stop sharing his presentation because we have to switch on to the next presentation. Okay, sir. Thank you.
Just give me a minute. Yes, can you see the screen now?
Yes, sir. We can see the beautiful view of Banaras.
Okay. So this is the topic on which I will be talking today. Yes, this is the topic on which I will be talking today, and this is our focus for the last few years. Basically, I am a computational person who later on started doing experiments as well. And now, in fact, I have a very substantial group, which, which many members.
इसमें Sorry to interrupt, Dr. Indrajit Sinha, sir. We are not able to hear it, you, sir. Requesting Dr. Indrajit Sinha, sir, you are not audible to us. Sinha, sir, your mic is switched off actually. Please put on your mic.
Switched off somehow.
Yes, sir. Now it is working. Yes, sir. Perfectly all right, sir. Please continue, sir.
You can see the PowerPoint presentation. It is still presenting. Hello. It is still presenting.
Yes, sir. It is visible, sir.
Okay, fine. Yes, so this is Varanasi, the Ghats of Varanasi, and this is the one of the main buildings of IIT BHU, and below uh, you can see this particular building.
Sir,
This is
your
an
slides,
overview. Yeah,
just a minute, sir. Your slides are not getting changed actually.
it is not getting changed.
Yeah, you are on the
Yes,
first
I'm
slide.
I'm stuck at the first.
Yes, sir. No, it's fine.
Can you see the slide now?
Yes, sir.
So this is the picture below is just an overview, a drone view of IIT BHU, and you can see the solar panels in IIT BHU. Okay, so I will take up two studies that we have done in recent years and published. So one of them is exploring the adsorption mechanism of three organic pollutants, phenol, paraphenol, and paranitrophenol on the magnetite surface. And this is primarily a molecular dynamic study. We do compare it with experimental investigations, but that is from literature. So, uh, over here, what we do is I'm just outlining the basic way in which the simulation is done. I will not go into the details. We basically take the magnetite supercell from we start from the unit cell and then we cut out a supercell from the and from that supercell we cut out the.
Again, sir, we are on the
Can you
second
see it
slide.
now?
No, so we are not able to see the change slides which are getting changed. So slides are not getting changed.
I am not getting it. Is
Yeah,
it now
yes, sir.
visible?
Yes, sir.
I think I will stay on this mode only.
Yes, sir. Now it's fine, sir. Please continue, sir.
Stick to this mode. Yes. So basically, what we are trying to understand is that look, experimentally, what you can get when you do an adsorption experiment, you get the thermodynamics information, that is the adsorption isotherms, and you get the kinetics information. But what you do not get is the molecular interaction information. That is, how does the organic molecule or pollutant or whatever adsorbate you are thinking of adsorbing on the adsorbent, how does that adsorbate interact with the adsorbent? The molecular interaction. What particular molecule is interacting and how? All right. Now, you may say that this can also be done by quantum mechanical approaches, but this is quite difficult with quantum mechanical approaches because we are dealing with bulk solid, number one. Number two, we also want to take into account the effect of solvent. All right. Now, in a real system, what is there? There is water and the organic molecule or any other adsorbate that you want to take out. So the water effect of water has to be taken into account. And basically, what you are tackling is a dilute solution. You are basically, when we are talking about remedying an aqueous medium, that is, we are trying to rectify its pollutant content. So, what are we trying to do? We are trying to tackle a very dilute water sample. So, basically, your pollutants are present in the water sample at the level of ppm or something like that. It's not in a very concentrated form. So that is what we have to take into account, that there is a huge number of water molecules. In those water molecules, you have very few pollutant molecules, but these few pollutant molecules are very, very
Sorry, sir, but
crucial.
again we are on the same slide.
No, I am still on the same slide only. Yeah.
Okay, okay, fine.
Okay. So, so what we are trying to say is that this is the that is different types of adsorbate we are planning, and it is in presence of water molecule that we are trying to talk about. This is the simulation beginning, that you take a simulation box of 3.4 nanometers into 3.4 nanometers into 4 nanometers. And these are the solute molecules at different concentrations. Whenever you plot an adsorption isotherm, you have to do the adsorption experiments at equilibrium adsorption experiments at different concentrations. So obviously we have also taken different number of organic pollutant molecules. And these are giving the particulars of the simulation. All right. So this is the slab. The slab, the first figure is the slab in the empty box. This is the magnetite slab in the empty box, and the upper side is empty and below side is empty. And in the second figure, we have put in the water molecules and the organic molecule. maybe chlorophenol or paranitrophenol, all right, one type of organic molecule. And then we have run the simulation, and it has got adsorbed onto the surface of the magnetite. So this is showing that adsorbed conformation. This is a snapshot. And another thing that has to be taken into account is that snapshots are not very useful over here, although it gives you a qualitative and picture which is very visually very attractive, that you can see how it is absorbing. But this is basically uh, you have to take a long time average and an ensemble average as well. So this particular this is giving you the density profile diagram for adsorption of adsorbates on the magnetite. And here these density profile diagrams are long time averages. These are long time averages. Okay, so the system has reached equilibrium, and once it is in the equilibrium, then we take the average of large number of time step production or property run. Okay, so that is what we are doing, densities at a large number of conformations. And one can see that it is adsorption on both sides of the slab, right? And these are all three are for different types of, this is the first one is for phenol, second one is for PCP, and third one is for PNP. In all the cases, one can see that the peaks are going down, the intensity of the peaks are going down with the concentration of the organic molecule. So this is then we plot these density profile diagrams. When we plot the information of these, uh, we integrate the area under the curves, and we get hold of the number of molecules which are bound onto the surface and number of molecules which are free, which are not bound onto the surface of the adsorbent. And then we plot according to different isotherm, that is, we can plot it according to Langmuir, we can plot it according to Freundlich. So this is a Freundlich fit, and these are giving the parameters over here. One can see that the Freundlich fit is also quite good. The R square over here for nitrophenol is around 0.95. For parachlorophenol, it is particularly good, 0.99. Okay. Now here we have not tried the Langmuir isotherm. Not tried. We have tried Langmuir isotherm actually, but we found that the data that was produced fits Freundlich much better, and that is why we have not presented the Langmuir isotherm. Okay, so basically it is fitting Freundlich isotherm better. All right, so these are the parameters which we have tabulated, and these are the adsorption energies. This is not actually kilocalories per mole. This is actually kilocalories for the whole system. So this is the whole system, and per mole you have to divide it by the relevant quantity. So you can see that the adsorption energies are going down. So the best adsorption behavior is shown by parachlorophenol, which means that the best adsorption behavior is shown by the parachlorophenol. And this is the adsorption equation, that is, you subtract the initial from the final, right? So you get the adsorption energy. This is the potential adsorption, potential energy of adsorption. Now, this gives you a very important information, this particular diagram, which is the radial distribution function, RDF or RDF, radial distribution. What is radial distribution function? Radial distribution function gives you the probability of a particular atom being in the vicinity of another atom at a certain distance. At a certain distance. So, for instance, here we are talking about FeM-OH phenol, which means that you are talking about the interaction between Fe atom of magnetite and oxygen atom of the phenol. Okay, so phenol has a oxygen phenol, that is OH phenol, functional group. So that oxygen of that particular functional group. So this is the interaction between the two. What you want to say is that what is the probability of finding an oxygen or phenolic oxygen at a certain distance of the Fe atom on the surface of the slab. So you can see there is a peak over here, all right, at around 3.2 or 3.5 angstrom, around that. And the other interaction between the oxygen of magnetite, Fe3O4, that is magnetite formula. So oxygen of magnetite and the H of phenol, that is the H of the hydroxyl, okay, of phenol. That interaction is not there, or it is very weak. So obviously this is the primary interaction. This is the primary way in which the magnetite interacts with the phenol. Okay. Then we this is of course showing the snapshot, and it is kind of showing that it may be slightly inclined conformation that we are getting. That is, the phenol is not flat, rather it is slightly inclined from the side of the OH, from the side of the OH onto the magnetite surface. Yes, so now we come to the next slide, which shows the radial distribution function for the PCP, that is parachlorophenol. Okay, parachlorophenol interaction with the magnetite surface. And here we see that the primary interaction is through this red curve that we are seeing. That is, this is between the iron of magnetite, iron atom of magnetite, and chlorine atom of parachlorophenol. In contrast to this, the interaction between iron and the phenolic hydrogen of magnetite is very weak. It's not there. Okay, sorry, and oxygen as well. So that is not there. So so basically, the primary interaction is through the iron and the chlorine of parachlorophenol. Associated with this is also oxygen and chlorine interaction, but this is only an associated interaction because they are in vicinity. So you are getting this particular curve as well. But this is the main interaction is the red one, which is iron and chlorine. And here also we see a partially inclined conformation from the snapshot. It is not very clear, but you can see that it is somewhat inclined in most of the cases. Right, then we have this PNP, paranitrophenol, which is interacting onto the surface. And this in fact shows that there are two almost equivalent interactions, which is iron magnetite and oxygen of phenol, paranitrophenol, phenolic oxygen of paranitrophenol. And then there is the also the interaction between iron of magnetite and nitrogen of nitro group of paranitrophenol. So which means that there are almost two equivalent interactions, two almost equivalent interactions. And you know that paranitrophenol, that means the phenolic group and the nitro groups are on the opposite sides of the benzene ring. So obviously these are flat. Both opposite groups are showing equal interactions, so they are flat onto the surface of the magnetite. They are adsorbing in a flat conformation, in a parallel fashion to the adsorption. Now we come to the next study. This is about an interfacial. This is a we extended the earlier study, which was just on adsorption, and tried to integrate it with our study on the experimental study on the Fenton reaction of star stabilized magnetite nanoparticle. So this combines two, that is experimental molecular dynamics as well as experimental study investigations. So the Fenton reaction is of course a very well-known reaction, and it's almost 100 years old now. And it is a green reaction, you know, because you are using only hydrogen peroxide, and hydrogen peroxide gets decomposed to the byproducts are is only water and oxygen. So there is no harmful product or anything like that. It's a green reaction. On the other side, you also generate hydroxyl radicals, which are extremely strong oxidants, and they are capable of oxidizing a very large number of contaminants. So there are two types of mechanisms which may happen when you are doing a catalysis. One is that the adsorbates are sitting on adjacent sites on the adsorbent, and then they react. That is, they are sitting on the adjacent sites and then they react. This is called the Langmuir-Hinshelwood mechanism. And the other type, these are two main types. Of course, there are variants of these mechanisms as well. Other type is that one of the reactants adsorbs and the other guy comes in from the solution phase or gaseous phase and interacts with this guy and gives you the product. So this is called the illyridial type mechanism. These are the two mechanisms, and there are, of course, as I said, there are variants of these mechanisms as well. But these are the main two mechanisms, and we are going to investigate that our particular study, that is this Fenton reaction, belongs to which particular class. And you may say that what is the importance of getting to this mechanism? The importance is once you understand the mechanism, then you can talk about and predict and design better nanoparticles, functionalized nanoparticles that can give you better Fenton reactivities, right? That is the idea. That is why you want to know the mechanism. Okay, so these are the objectives that we want to propose the surface mechanisms by understanding the interfacial distribution of chemical species from MD simulations, and we combine it with experimental results. So the first step is that we want to find out how does PNP, paranitrophenol, this is the pollutant that we are degrading. How does paranitrophenol in presence of hydrogen peroxide and water adsorb onto the surface of magnetite only? Okay, only magnetite cluster. All right. And in the second step, we see that how when we functionalize the cluster with starch, when we functionalize the cluster with starch, then how does this affect the distribution of various molecules around the starch stabilized magnetite nanoparticle? Okay, so these are the two parts. We go to the experimental part. The experimental part is a simple synthesis of magnetite nanoparticles. So we make both types of nanoparticles. We have not detailed given the details of magnetite, simple magnetite synthesis that is well known, but we add starch to it, the same protocol, and get the starch functionalized magnetite nanoparticles. These are the XRD patterns, and these show that magnetite has been formed in both cases. So there is no issue about the synthesis part, and these are the same images. So you can see that the magnetite nanoparticles, the particle sizes are bigger. As star stabilized magnetite nanoparticle, the particle sizes are finer. All right, in fact, substantially finer, because starch covers the surface and thereby prevents the aggregation of various particles during the synthesis and thereby growth to a larger size. So it caps the size of the nanoparticle to a very fine particle size. All right, then we attempted the degradation of paranitrophenol, and we tracked the degradation of paranitrophenol using UV visible spectroscopy. That is, paranitrophenol in acidic medium shows a peak at around 350 nanometers, 340, 50 nanometers. And this is the peak that we are tracing, we are investigating, as it should go down with time if paranitrophenol is getting degraded. 317, right, nanometers. So what we find is when we have only magnetite nanoparticle and no starch stabilization of the same, then what we see is that it does degrade, but it is quite slow. The whole degradation, the degradation takes around 210 minutes. You can see from the figure, and furthermore, it's only degrading around 40% of this nitrophenol. It's not complete degradation either. Then we go to when we use star stabilized nanoparticles instead of this only magnetite nanoparticles, we see a drastic change. That is within 80 minutes. Within 80 minutes, almost all of the paranitrophenol is degraded. Almost all of the paranitrophenol is degraded. Okay, so you can see that. So it's a substantial change, significant change, and you can see the kinetics plot over here. This is the first order kinetics, and you can see that the rate has increased substantially. In fact, drastically, one may say. Now we did the molecular dynamics investigations to find out why does this happen. It is on when we stabilize it with starch, then why does this drastic change in kinetics happen? So again, I will not repeat this part that how did we construct the model and all that. So this is the cluster that we used over here, right? This is a magnetite, and this is a star stabilized magnetite cluster, nano cluster. And this is the complete simulation box. You can see that it shows the starch units in the blue encircled regions, and then the then the H2O2 and the water molecules, and it also shows the paranitrophenol molecules. Now this is a slightly different radial distribution function because it again shows the probability of finding a molecule from a particular at a particular distance from another molecule, but now it is taking into account only the center of mass of the molecules because these are large molecules. So we also showed the center of mass molecules, RDFs, and we find that PNP adsorbs very strongly to the magnetite cluster. There is no star stabilization over here. Remember, there is no star stabilization over here. This is the first simulation, and we found that PNP adsorbs very strongly. In fact, H2O2 adsorption is quite weak over here. H2O2 adsorption is quite weak over here. All right. So that is a problem because the Fenton reaction proceeds by what mechanism? That is the cleavage of H2O2 to hydroxyl radical to give you hydroxyl radical. So unless the cleavage of H2O2 happens, nothing is going to happen, right? So H2O2 cleavage is an essential part, necessary part, which is required before anything you can get any further in the story. Now, what did we do? We also tried it with starch stabilized magnetite cluster. So the pink is the starch network. All right. The previous one was only magnetite cluster, and here it is starch stabilized magnetite cluster. All right. And it is showing H2O2, the red, and the nitrophenol as well. Now we see a contrast, completely different story. That is, the red curve is star stabilized magnetite cluster and H2O2 interaction, and this is quite strong. Star stabilized PNP also interact with the starch covering, but it is weaker than the H2O2 interaction, which is as we require. That is, now H2O2 is interacting very strongly with starch. Now, I would like to say here that H2O2 with starch does not give you any cleavage of H2O2. It does not give you any OH radicals. All right. So starch does not play in any role in this Fenton reaction. It only plays the role of an attractor. That is, it is attracting the H2O2 molecules to its side through a hydrogen bond kind of thing, a weak interaction, an interaction, and it is interacting with PNP as well. All right. But H2O2 being very small, it can penetrate the starch network. Can penetrate the starch network. Okay, I will skip this slide. This is another detailed RDF which shows the atom to atom interaction. I will leave this slide again. And these are again detailed RDFs which give you the details of the interactions, how they are interacting, every other group and all that. This is the interaction energy. Now you can see the interaction energy that RM2, which is the star stabilized cluster, has a much higher interaction with the rest of the system, which is the H2O2 water plus PNP. while RM1, which is only magnetite cluster, has a weaker interaction. So obviously this interaction, the latter one is much stronger. Okay, so basically it tells us that uh, there are we now note down the points. That is, the Fenton activity of star stabilized magnetite nanoparticles is more than magnetite nanoparticles. This is the experimental result. And experimentally, we have also found out that starch does not have any effect on the Fenton PNP degradation. So, in conclusion, we can say that H2O2 cleavage happens only on magnetite surface. This is well known from literature as well. The RDFs show that starch molecules covers the magnetite nanoparticle and prevents the larger PNP from getting to the magnetite surface. And these starch stabilized magnetic cluster is surrounded by much smaller H2O2 molecules, though PNP is also in the vicinity. All right. So just it is cutting down. So basically, now we can say that ER mechanism, which requires that only one reactant reacts with the active site on the cluster, but other reactant remains near to the catalyst surface. This is very vital. That other reactant must be near to the catalyst surface. Remember, H2O2, when it is cleaved to give you OH radicals, the OH radicals have a very short lifetimes in the order of nanoseconds. Now, within this nanoseconds, it cannot travel very far. It will die. That is, it will be consumed by some more stable species. So, what does it require? It requires the organic molecule which you want it to react with should be nearby. That is, within the time, that is nanoseconds time that you are giving it, that is lifetime, within that time it can find that guy and interact with that guy. So we come to the conclusions that cleavage of hydrogen peroxide to hydroxyl radical requires the interaction of H2O2 with the catalyst surface, number one. Number two, adsorption of PNP molecules onto the magnetite surface when there is no starch stabilization. Then it poisons it partially. That is, it covers it and does not let H2O2 approach it at all. It has a very strong interaction with the magnetite surface. So H2O2 is not approaching, nothing is happening. When you cover the magnetite surface with starch, then it favors then it favors H2O2 adsorption, and it also interacts favorably with the PNP. Okay, so H2O2 adsorption happens onto the starch and it can diffuse through the channels in the starch, the porous network of starch. Starch is a natural polymer, remember? So it diffuses through the pores of the starch and goes to the magnetite surface and gets cleaved, reduced to OH radical and OH minus hydroxide anions. And hydroxyl radicals then come back and interact with the PNP, which are very nearby, which are also interacting with the starch. Okay, so H2O2, so as I said, it is able to penetrate the starch network and reach the magnetite surface, and the PNP, which is a much larger molecule, cannot penetrate and it remains near. So this results in a much rapid reaction with the generated hydroxyl radical. So this complete study shows us that for a Fenton reaction, number one, it is critical that the H2O2 must adsorb onto the adsorbent. If the pollutant adsorbs more strongly, then it will poison the surface. But you must have the pollutant nearby as well. It should not be very far away, because then OH radicals which are generated will not be able to interact with it. If you have a Langmuir-Hinshelwood kind of mechanism, then it is very good that both are adsorbed onto the surface and they can interact. But if you don't have it, then you have to go for an illegal kind of mechanism. So basically, you have to have a stabilizing molecule like starch or something else, which can bring the H2O to close to the surface of the adsorbent or the catalyst. Okay. So with this, these are the publications and the references that we have used in this particular talk. And this is the my group photos, some of my students. And I would like to thank you all for giving me this opportunity to discuss this problem with you people. And this gives the photograph Param Shivai and IIT BHU logo. Thank you.
Thank you so much, sir. It was a remarkable lecture, and it was wonderful listening to you, sir. Thank you so much for sharing your profound knowledge with all of us. Once again, thank you so much, sir. So let's start further. The most awaited session has come, and we rarely get this kind of opportunity where we are blessed to listen to the words of a great knowledgeable speaker. I deem it as a proud privilege and my honor to welcome and invite our next distinguished speaker, an eminent name in the field of chemical science, Dr. D.V. Prabhu. He is the former head and adjunct professor at the Department of Chemistry, Wilson College, University of Mumbai. And his topic for today's session is Role of Catalysis in Sustainable Chemistry. I warmly welcome with folded hands Dr. D.V. Prabhu, sir. We welcome you to the session. Over to Dr. Prabhu.
Hello.
Hello. So your PowerPoint presentations will be open via.
Yes, yes.
So we are opening them. So this is role of catalysis in sustainable chemistry. So is it visible to you?
Yes, yes. It is.
Okay, so please continue. Thank you, sir.
Okay. Good afternoon, friends. It's a great pleasure to be with all of you this afternoon. I am thankful to Professor Shailendra Yadav for inviting me to give this talk in this international webinar on the recent contributions of the chemical sciences to the modern society. Chemistry has contributed a lot to the welfare of society. Chemistry caters to all the requirements of mankind.
Sir, sorry to interrupt you, sir. Actually, your voice is getting echoed.
Yes, please.
Sir, your voice is getting echoed.
Getting
So
repeated.
maybe you have logged in twice. Because on the screen it is showing that you have logged 2 times. So, are you also connected with us through
Hello,
mobile?
can you hear me?
Yes, sir, we can hear you easily. Sir, are you also connected with us through mobile? No. Hello, sir. Now it is okay. Please continue, sir. Hello. Sir, please continue.
Hello.
Hello. Yes, sir, please continue. You are audible to us now. Hello. So your microphone is off. Please turn on your microphone, sir. Yes, sir. It is fine now.
हेलो हेलो
Hello. Yes, sir. It is fine now. Please continue your lecture.
यार बिजी है जरा जरा नहीं नहीं अभी मत करो 1 घंटे के बाद फोन करता हूँ ठीक है
Prabhu sir, we can hear you now. You please continue your session, sir. Hello. Can you hear me, sir? Hello. Prabhu sir, please continue.
हेलो हाँ जी नहीं कैसे मैं प्रोसीड करूँ क्या आपको सुनाई दे रहा है हेलो अच्छा अच्छा ठीक तो मैं स्टार्ट करता हूँ हाँ अभी पहले स्लाइड ही रहने दो मैं बोलता हूँ चेंज द स्लाइड तो चेंज कीजिए ठीक है हाँ हेलो अगेन गुड आफ्टरनून टू ऑल ऑफ यू chemistry has contributed a lot to the welfare of society because it looks after all our requirements food, shelter, clothing, medicine, energy. In the past few years, chemistry has made exponential progress and several new materials have been synthesized. Just to give you example, nanomaterials, nanomedicines, polarines, semiconductors, superconductors, and so many others. We can rightly say that chemistry is the science of life because life depends on the chemistry. There is a continuous search for new catalysts which are very effective, and therefore my topic today is role of catalysis in sustainable chemistry. Catalysts play a very important role in sustaining life on this planet. And today, there is a continuous debate between the conservation and the development. And finally, we have come to the conclusion that there should be some balance between the development and the conservation. Next slide, please. Next slide. Today I will be covering the following points. What is sustainable chemistry? We are hearing so much about sustainable development, and chemistry has to play a very important role in sustainable development. Concepts of catalysts, which are the main pillars of green chemistry. Just I will give a brief revision of the concept of catalysis. Then the role of catalysts in sustainable chemistry, mainly to improve the atom economy and improve the yield of reaction with some industrial examples. Then the new idea of green catalysts, that is catalysts which are environmentally friendly. I will mention three important green catalysts: the biocatalyst, which use enzymes, the nanocatalyst, and the phase transfer catalyst. Then the conclusions and some references. Next slide, please. Sustainable chemistry. As I mentioned, there is always a vigorous debate between development and conservation. And sustainable development seems to be the answer. Sustainable chemistry aims at design of products that minimizes the use and generation of environmentally harmful materials. That is, starting material should be environment friendly and products also should be environmental friendly and should not degrade the environment. Sustainable chemistry has three main aims: prevention of waste and pollution. That is, maximum amount of the reactant material should be converted into products, and products also should not pollute. Second aim, saving of energy. That is, reaction should be done preferably at room temperature, that is ambient temperature. And third, ensuring safety in chemical processes. That is, use of substances with minimum potential of accidents. Sustainable chemistry is a scientific concept that aims at improving the efficiency with which natural resources are used to meet the needs for chemical products. We all have to accept that we require chemical products right from the time we get up in the morning till the time we go to bed. All the substances which we use are prepared by chemical industry. So we have to find a way by which we will use our reactants efficiently, and the products also should be environment friendly. Sustainable chemistry is based on the 12 principles of green chemistry given by Paul Anastas and John Warner, who are the fathers of green chemistry. And the three R principle: reduce, reuse, and recycle. Next slide, please. Now let me explain briefly what we mean by the three aims. First is prevention of waste and prevention of pollution. This is done by maximizing atom economy. That is, maximum number of atoms of the reactant should be converted into useful products so that very few atoms get wasted. In other words, 100% atom economy means 0% waste. Trying to avoid derivatization wherever possible, because derivatization means more use of chemicals and more production of products. Energy saving by using catalysts to lower the energy requirement of the reaction. Use of renewable feedstocks. Renewable. For
Prabhu sir, we are not able to hear to you, sir. Hello. So we can't listen to you, sir. Due to some technical reasons, Dr. Prabhu could not be able to join to us. Within a short period of time, he will get connected back to us. Please stay tuned to us. Thank you. We are trying to connect with Dr. Prabhu and he will shortly join us. We will he will take another 2 minutes to rejoin the session. Thank you. So, proceeding further and taking the session to the next level, I would like to invite and welcome Dr. B.B.L. Srivastava, Professor at College of Natural and Mathematical Science, Department of Chemistry and Forensic Science, University of Dodoma, Tanzania. His topic is very interesting and is related to the pandemic, which causes the global health crisis of our time and the greatest challenge we have faced since Second World War. Yes, I'm talking about the coronavirus COVID-19 pandemic. And his topic for today's discussion is COVID-19 modern medicine and role of medicinal plants. I proudly welcome and invite Dr. B.B.L. Srivastava from University of Dodoma, Tanzania. Over to Dr. Srivastava. We request Dr. Srivastav to please go ahead for this session. Dr. B.B.L. Srivastav. We are requesting you to please present your PowerPoint slides. Due to some technical reasons, we are not able to connect to Dr. B.B.L. Srivastav sir at Tanzania. Shortly, he will join us. Hello, Dr. Sundaram Singh. Hello, Dr. Sundaram. Madam, are you ready with your presentation? Should we make a call to you?
I am ready.
Okay, ma'am. Thank you so much. So our next distinguished speaker for our session is Dr. Sundaram Singh, Associate Professor at IIT BHU Varanasi, and her topic for today's discussion is Visible Light LED Induced Organic Reactions, Applications in Organic Reaction. I would like to invite and warmly welcome Dr. Sundaram Singh from IIT BHU. Over to Dr. Singh.
Good afternoon, everybody, and thanks for giving me opportunity to deliver the lecture. So now I will start. Uh, Can I start?
Yes, ma'am.
Okay. So the topic of my presentation is Visible Light LED Induced Organic Reactions, Application in Organic Synthesis. First, I'd like to talk about the visible light. In 1912, Siamin recognized that sunlight could be used as renewable energy source for organic synthesis. And now from that, the concept of visible light come into consideration. Visible light as a clean, cheap, and almost infinitely available source of energy has received increasing attention from the chemistry community. Over the past decade, visible light promoted uh, from reaction exposed several important applications due to their important characteristics such as simplicity, safety, cost effectiveness, and sustainability. That's why it is a part of the green chemistry. Visible light driven organic transformations are not only attracting a great attention of the synthetic community, but also have opened up a superior way to construct challenging carbon-carbon and carbon heteroatom bonds in a highly selective manner. Recently, visible light alone or in combination with an appropriate catalyst has set the remarkable advances and enable numerous expedient synthetic manipulations which were earlier inaccessible by traditional thermal methods. Now in 2008, Macmillan and co-workers reported the first example of combining photoredox catalyst with visible light. Visual light initiated reaction occurs in two ways. First, visual light initiated photocatalyst free reaction and visual light initiated photocatalyzed reaction. Since most organic molecules cannot absorb visible light efficiently, and the choice of photocatalyst is crucial for the successful course of a visual light photo reaction. A good photocatalyst not only has good chemical stability and a long excited state lifetime, its redox potential can also be easily modified by the coordinative ligand. Because without coordination, there is no excitation of the molecule, and to that day, the commonly used photoredox catalysts include ruthenium or iridium, polypyridyl complexes, and metal salts, as well as organic dyes such as rhodamine A, rhodamine B, rose vinegar, eosin Y, etc. Now, the photocatalyzed reaction occurs in two ways. First is hydrogen atom transfer catalyst, and second one is single electron transfer catalysis. Now, I would like to first discuss about the visual light mediated catalyst free reactions. So this is the example of visual light mediated catalyst free condensation of barbitric acid with carbonyl compounds such as aldehyde and acetylene. The most important thing here is that the 1 mole of barbitric acid is going to combine with 1 mole of aldehyde, whereas in the same condition, 2 mole of barbitric acid is going to combine with the 1 mole of the acetylene to provide the dibarbitrates under the same reaction condition. Now the highlights of this reaction. This is a catalyst-free reaction, high yield of the product, And without column chromatography, we get the pure product and short reaction time. In order to see the type of the product, we have screened the molar ratio of substrate, and now at any proportion or at any molar concentration, this the reaction between these two provides the dibarbitrates. There is no change in the type of the product. There is only change in the yield of the product at any molar ratio. And now the better result was obtained in 1:2 molar ratio. In the similar way, the reaction of these two, that is aldehyde and barbitric acid, was also screened. And now again, it is found that there is only change in the yield of the product. There is no change in the type of the product. In order to study the scope and limitations of this reaction, various acetine, that is N substituted and 5 substituted acetine, were subjected to the reaction with the barbitric acid to provide dibarbitrates in good to excellent yield. So these are the substrate scope for this reaction. Similarly, various aromatic aldehyde, that is electron releasing as well as electron donating, electron releasing as well as electron drawing group containing aldehyde is subjected to react with the barbitric acid and provide good to excellent yield. In order to find the mechanism, some control experiments were carried out in presence of the radical scavenger tempo, and now the reaction was carried out with 2 equivalent of the tempo. In that case, there is only 12% of the product was formed, and now with 5 equivalent of the tempo, no product was formed. Again, aldehyde reacts barbitric acid with 2 equivalent of the tempo, only 14% of the product was formed, and with 5 equivalent, no product was formed. This reaction indicates that there is involvement of radical mechanism. Some other control experiments are also carried out, like benzaldehyde reacts with barbitric acid in presence of DAR. In that case, there is only trace amount of the product was formed. When this reaction carried out at 50 degrees centigrade, no product was formed. These two reactions indicate that there is involvement of the visible light, means this reaction occurs only in presence of visible light. Now, when the reaction was carried out in presence of nitrogen atmosphere and hydrous condition, the dibarbitrates was formed in 91% yield. This reaction indicates that there is no role of oxygen in this reaction. Similar reaction was carried out with aldehyde, and now these two reaction indicates the importance of visible light, and 90% of arylidine derivative formation in presence of nitrogen atmosphere and in anhydrous condition indicates that there is no role of oxygen in this reaction. On the basis of control experiment and reported literature, this mechanism was proposed. First of all, acetine was excited with the help of visible light to form this diradical. This diradical abstract hydrogen radical from the barbitric acid to provide this radical, and now these two radicals combine together to form this intermediate A after the removal of water. And now again this intermediate A was excited with LED to provide this biradical. This biradical abstract hydrogen radical from barbitric acid and follow the same path to provide the dibarbitrates. Now the mechanism of the reaction of aldehyde with barbitric acid in the similar fashion. Aldehyde, the carbonyl oxygen of the aldehyde is excited to form biradical, and now it abstracts the hydrogen radical from the barbitric acid to provide this radical. This radical is going to combine with the barbitric acid radical to provide the ultimate product with the removal of the water. Now again, next example is the catalyst free visible light mediated multi-component synthesis of naphthopyranopyrimidine under aqueous condition. The synthesis of naphthopyranopyrimidine was achieved by the multi-component reaction of various aromatic aldehyde, barbitric acid, and hydroxy compound under visual light irradiation in water at room temperature. The highlights of this reaction is that this is the catalyst-free reaction. Reaction occurs at room temperature. This is metal-free condition, non-chromatographic separation, water used as a green solvent. Again, in this reaction, we see the effect of the molar ratio on the substrate. And now the result of this table indicates that there is no change in the type of the product. There is only change in the yield of the product. And now the best result was obtained by the molar ratio of benzaldehyde, barbitric acid, and beta-naphthol 1:1:1. In order to find the substrate scope, various aromatic aldehyde, that is electron donating as well as electron releasing withdrawing group containing aldehyde were subjected to the reaction with barbitric acid and substituted beta-naphthol to provide the product, and the reaction proceeds satisfactorily in all cases to provide the good to excellent yield. Now, in order to find the mechanism, some control experiments were carried out when this multi-component reaction carried out in presence of two equivalent of tempo. Only 9% of the product was formed, and now with 5 equivalent, no product was formed. This reaction indicates that there is involvement of the radical pathway because this barbitric acid is going to trapped by the tempo, so the reaction does not proceed. Now, in order to find the importance of visible light, these two reactions were carried out. When this reaction occurs in dark, only trace amount of the product was formed, but at 50 degrees centigrade, no reaction occurs. These two reactions indicates that visible light is essential for this reaction. On the basis of a control experiment and reported literature, this mechanism was proposed. And as in previous chapter, the aldehyde was first excited with the help of LED to provide this biradical. This biradical abstract the hydrogen from barbitric acid to provide the intermediate A by this path. And now this intermediate A reacts with the excited hydroxy compound to provide this one. This upon cyclization and removal of water provide the ultimate product, that is pyrimidine. Now we come to the photocatalyzed organic transformation. This is the example of hydrogen atom transfer catalyzed reaction. Visible light mediated synthesis of 3-amino-imidazo 1,2-A pyridine using eosin Y as a photocatalyst through hydrogen atom transfer catalysis. The synthesis of amino-imidazopyridine achieved through the multi-component reaction of benzylamine, 2-aminopyridine, and isocyanide under visual light irradiation in ethanol water combination. The highlight of this reaction, that is cheap eosin Y is used as a photocatalyst. This is hydrogen atom transfer catalysis. Now this is a one-part multi-component reaction and room temperature reaction, and there is formation of new CC and CN bond. In order to study the scope and limitations of this reaction, various benzyl amine were subjected to the multi-component reaction, and now in all cases good to excellent yield was formed. In order to find the control experiment, in order to find the mechanism, some control experiments were carried out, and when this multi-component reaction carried out, we get the product 4A. And now only these two, that is benzylamine and 2-aminopyridine, were subjected to the standard reaction condition. There is formation of the enamine 5, and now when only benzyl amine is subjected to the reaction, the 6, that is enamine, was formed in 85% yield. When this reaction carried out in absence of usine Y, no product was formed. So this reaction indicates that there is importance of the photocatalyst using Y. Now when this reaction again carried out, that is the in presence of visible light containing usine Y as a photocatalyst, and with 2,4-DNP, 2,4-dinitrophenylhydrazine, no orange precipitate was formed. There is only formation of the compound 6. This indicates that there is no involvement of the aldehyde, that is, there is no oxidation of this benzyl amine with the help of usine Y in aldehyde, and now it is going to be converted into enamine, and there is involvement of this intermediate. On the basis of control experiment and reported literature, this mechanism was proposed, and now this is the example of hydrogen atom transfer. First of all, usine Y is going to excite it with the help of the visible light and form usine Y, excited usine Y, and now this benzyl amine transfers the hydrogen to this excited usine Y to form the usine YH and intermediate A after the hydrogen atom transfer. And now this hydrogen atom transfer converted into usine Y by transferring their hydrogen to the molecular oxygen, and this molecular oxygen is converted into the hydroxyl radical, which is converted into the H2O2 and O2. Now the intermediate A again transfers hydrogen from here to the molecular oxygen to form the intermediate B, and now oxygen is converted into HO2 radical, which is ultimately produce H2O2 plus O2. Now this intermediate B is going to react with the 2-aminopyridine to provide this one, and this upon removal of the amine provide intermediate C, and this intermediate C, that is enamine, is going to react with the isocyanide, which is activated through the photochemical reactions, and provide the intermediate D. This intermediate D upon rearrangement and cyclization and tautomerization form the ultimate product, that is imidazole 4A. Now then, this is the example of the single electron transfer, that is visible light induced copper catalyzed synthesis of escape space of 2-aminobenzonitrile derivative and acetophenol. This reaction carried out with the CuCl only in 3 hours. So the highlights of this reaction is short reaction time, excellent yield, low cost setup, room temperature. There is only one previous report on the synthesis of the escape space of aminonitrile by using paratoluene sulfonic acid in 12 hours at high temperature, that is 135 degree centigrade. And now by using visible light, we have developed the efficient synthesis of escape space under visible light in 2 hours, 3 hours. In order to find the substrate scope, the various aminonitrile and the various estophenol were subjected to the reaction. In all cases, the reaction proceeds satisfactorily to provide good to excellent yield. Now, in order to extend the applicability of this reaction, aldehyde was also subjected to the reaction, but with aldehyde, there is no formation of the escape space. This reaction occurs at thermal condition. Now, this reaction is also valid for the Gram scale reaction. In order to find the mechanism, some control experiments were carried out. First of all, when the condensation of these two carried out in presence of tempo, only trace amount of the product was formed. This reaction indicates that there is involvement of the radical mechanism. And now if this reaction was carried out under nitrogen atmosphere, only 10% of the product was formed. This reaction indicates that there is involvement of the oxygen. Now, in order to find the intermediacy of the copper complex in this reaction, already prepared or synthesized copper complex were subjected to the reaction with the acetophenone. In that case, there is 97% yield of the product was formed. This reaction indicates the intermediacy or confirms the intermediacy of this copper complex in this reaction. On the basis of reported literature and control experiment, this mechanism was proposed. First of all, amine reacts with CuCl to provide the copper first complex 4. And now this is going to be excited with the visible light to provide this excited intermediate 5. This excited intermediate takes the electron from the molecular oxygen to provide the copper 2 complex 6. And now the superoxide ion, this superoxide ion is going to dissociate to H2O2 and O2. This intermediate 6, that is copper 2, which is obtained by the single electron transfer from the intermediate 5, is going to react with the activated acetophenone, provide the complex 8, which is going to provide the ultimate product by the removal of the water and regenerate the catalyst CuCl. Now, in last, I would like to conclude my lecture. It is clear that visible light-induced reaction will offer practitioners of organic synthesis with new tools to apply to a number of fields. The surprising array of reactivity, including cycloaddition, condensation, cyclization, synthesis of escape base, and multi-component reaction, etc., holds promise for utility in organic synthesis. Noteworthy is the overall mild nature of the reaction conditions that are tolerant of a variety of complex functionality. Despite the significant advances in the field of visible light-induced reaction, there remain many opportunities for further exploration. This area is sure to bring a wealth of interesting and important science for decades to come. Thank you.
Thank you so much, madam, to grace our program to your presence and glory to our webinar. Thank you once again. Now, proceeding further and taking the session to the next level, I would like to invite and welcome Dr. B.B.L. Srivastav, Professor at College of Natural and Mathematical Science, Department of Chemistry and Forensic Science, University of Dodoma, Tanzania. And his topic for today's discussion is very interesting, which is related to the pandemic of coronavirus COVID-19, and which causes the global health crisis in our time, and it is supposed to be the greatest challenge since Second World War. I would like to invite and warmly welcome Dr. B.B.L. Srivastav, sir. Over to Dr. Srivastav.
Thank you, madam. Thank you, Dr. Shailendra Yadav, to invite me to this wonderful international seminar, recent contribution of the chemical science to modern society. In this continuation, I am going to present the COVID-19 modern medicine and role of medicinal plants. So, let us share the window. screen is
Yes, sir, we are able to.
visible?
Yes, sir, it is visible to all. You please
Okay.
proceed further.
Okay, thank you. So today, my topic is COVID-19, modern medicine, and role of medicinal plants in the prevention of the COVID-19. So my whole talk divided into four parts: the introduction about the COVID-19, modern medicine, and role of submedicinal plants, and recommended Ayurvedic medicines. So we know very well this coronavirus is caused by the severe acute respiratory syndrome, and it's originated in Wuhan, China since December 2019. And WHO discovered this is a pandemic disease in 11th March 2020. So coronaviruses are a pathogens for human and animal prior to 2003, but a number of coronaviruses is known to cause a severe disease in animals before 2003. But this changes with the zoonotic transmission, means transmission from the animal to the man, and it's a very potentially fatal severe acute respiratory syndrome coronavirus that is called SARS-CoV in 2003, and MERS, Middle East Respiratory Syndrome COVID in 2012, and it's a very serious diseases. And now from 2019, we are facing SARS-CoV-2. It's a pandemic in the whole world now. So just we are going to talk about what is the coronavirus and how it's multiply in the human beings. So coronavirus, it's having the total 39 species under a very broad realm of the riboviria. The family, Coronaviridae, suborder, Corona order Nidovirinae, and genus. It's a type of classification that's why it's called beta coronavirus. So all SARS-CoV fall under the species severe acute respiratory syndrome that is related to the coronavirus. So we know now the currently 7 types of coronavirus are confirmed in the human beings. That 2 belongs human coronavirus, that is the NL63, and human coronavirus 229E that belongs to the genus alpha coronavirus, and it's very less severe, just cause the cough and cold in the human beings. But 5 other coronaviruses that belongs to the beta category, and that human coronavirus 43, human coronavirus HKUI. But the upper 2 are not very fatal, not very severe. But lastly, from 2003 onwards, SARS-CoV, MERS-CoV, and 2009 onwards, SARS-CoV-2. So these 3 are very, very fatal for the human beings and belongs to the beta coronavirus.
Hello,
Now
sir.
we are going.
Excuse me,
Yes.
sir. Sorry to disturb you,
Yes.
sir. Your slides are not changing actually.
It's not changing.
Yes, sir. We are on the previous slide since you started.
Not sharing.
Still, it is not,
Hello,
sir.
madam.
Yes, sir. Now it is working. Now, sir, it is fine.
It's fine.
Yes, sir. Now it is fine, sir. You please continue.
Okay. So
Sir, it's better
that
you go to the first slide or start from there, because since long you have started, we are not able to see that. But previous first slide,
okay, madam.
because many of the viewers are connected with us for your lecture, so that's why I'm saying this. Yes, sir. Thank you so much, sir.
So now you are in. Okay.
Yes, sir. Perfectly all right, sir. Please continue.
It's not sharing here. So the whole talk have the 4 parts. We already discussed introduction about COVID-19, modern medicine, and role of some medicinal plants, and also recommended Ayurvedic medicine, Indian medicine. So now, so currently 7 coronavirus have been confirmed in the human beings. So coronavirus NL63 and human coronavirus 22E, that is belongs to the alpha coronavirus category, and that is not very fatal to the human beings. But 5 other coronavirus, human coronavirus 43, human coronavirus UKI, it's 5 above 2, that is not very fatal, that is cause the severe infection in the like a common cold and cough and sneezing. But there are 3, SARS-CoV-2, MERS-CoV, and SARS-CoV-2, it's starting from 2009, belongs to the beta coronavirus category, are very fatal to the human beings. So these viruses, it's not showing. Madam, it's visible to see the screen. Hello. Hello. What's the problem? Hello.
Oh, yes, sir.
Yeah, you are able to see the screen?
Yes, sir. Yes, sir. It is going perfectly, sir.
Okay. So now we are going to talk the structural assembly of the coronavirus. The coronavirus belongs to the large family of RNA virus, and its genome, it's very long, 27 to 32 kilobase base, means approximately to 125 nanometer. It's a big, the size is big. So it is a single stranded RNA, possesses a positive sense RNA genome, also known as plus S RNA. Basically, the virus have the 4 important structural protein, that is called envelope protein, membrane protein, spike protein, and nucleocapsid. You see the here structure. Here in structure, the corona virus have the spike. The spike, we are going to talk why this spike called the corona, nucleocapsid, membrane, and envelope of that viruses, and that is the RNA genome. So this is the complete structure of the coronavirus. So among these, what we are talking, the 4 proteins, the most important one is the nucleocapsid and spike protein. So the spike protein has 3 major sections: large ectodomain, single constant member anchor, and short intracellular tail. So these spike protein play a very important role in anchoring the host cell. You see in the next slide, the spike protein divided into 2 parts: S1 receptor binding subunits and S2 receptor bind units. So S1 is the attached with the cell, and S2 fused with the nucleus. I will show in the picture. So these subunits in the corona, it's like a closed trimeric, means like a crown structure. And that's why the reason coronavirus got the name corona. Corona means crown. Like you see, when you see there is a crown on the globe, so similar structure like that. So SARS-CoV have the 2 receptors, the receptor binding domain and receptor binding motif. You see here in this picture, see this coronavirus, the spike protein having the 2 upper region, the binding region, S1 and S2. S1 is a trimeric, and that is the variation in the different strain of the coronaviruses. Because with the help of this trimeric crown, it attached with in the lungs, there is a angiotensin enzyme. So it is attached with that, and then S2 region fused with the cell of the lungs, alveoli. And when it's going to be fused with the cell, so it will got multiplication, inflammation will happen, fever is going to generate, and virus replication in your lungs. That's why it's a called respiratory problem first when the coronavirus enter in your system. So during SARS infection, the binding motif of the S protein get directly attached to the angiotensin converting enzyme, means that is a receptor in the human host cell. And where its receptor is finding, the angiotensin converting enzyme basically in finding in the human organs like lungs, kidney, intestine. So this is the prime target of the coronavirus because there is a receptor that is called angiotensin enzyme. So SARS-CoV-2 infect host cell through angiotensin enzyme receptor, leading to COVID-19 related pneumonia. And while also this pneumonia causing acute myocardial injury and chronic damage of the cardiovascular system also. That's why most of the people, those who are suffering from the coronaviruses, the death happened because of the heart attack. So you see the angiotensin enzyme 1 and angiotensin enzyme 2 have gained recognition as a significant regulator of the physiology and pathology of the reproductive system also. But still there is no report to prevent they reduce the male potency and sexual potency decreasing. So now when you see when the individual are affected, possible affected individual, so this coronavirus is going to be enter through the nostril in the lungs, and the spike protein attached with the angiotensin enzyme, that is a receptor of that coronavirus, and it will fuse with that epithelial and alveoli cell, and it will multiply in the lungs. So when the multiplication happened, the lungs got inflammation, and you have a respiratory problems, condition in the lungs and different problems. So and finally the cardiovascular injury happened and people will going to die. So you see, so the replication of the SARS-CoV, after the SARS-CoV virus has entered the human host cell, the next step for the virus is survival, it's RNA replication, because that is, as you know. So what is the tool that are required for the process of replication of this virus is open reading frames. And what is that? The open reading frames to replicate genes, a slippery sequence, this is the sequence of the genome, and two polyproteins, that is a PPLA and PPLAB. So these three are responsible for the replication of the this coronavirus inside the body system. So these polyproteins contain the most important protein of the virus, that is called nucleoprotein, and that nucleoprotein from 1 to 11 and 1 to 16. So here the nucleoprotein in the virus. So recently the researchers shows that NSP15, nucleoprotein 15, have not only have a viral role in the replication, but also attack the immune system of the host during the virus replication. So this nucleoprotein, this assembly, replicates transcriptase complex, which create an environment inside the host body suitable for the RNA synthesis and replication of the coronaviruses. So nucleoproteins have various role in RNA application for the viruses. So nucleoprotein coded RNA dependent RNA, nucleoprotein 30 encrypted RNA helices, nucleoprotein 15 included exoribonucleobases, and nucleoprotein 16 included this encoded tau-methyl transferase activity. So these evidences prove that the nucleoproteins have a vital role in keeping the virus alive inside the host body by promoting basic synthetic replication and transcription of the viruses. So when the virus replication in the inside the body system, so the genomic RNA that contain 5' region and translate leaders, that was sequence of the RNA with the transcription regulation, present the descending region of the genome. So here you see the replicate genome encoded enzyme uses the negative RNA genome as a template to develop a small overlapping messenger RNA molecule that further get translated into the structural protein, and that structural protein, nucleoprotein, this envelops spike protein. So this is the building blocks of the production of the viral in the host cell. So while the positive standard RNA genome is used as a template to produce a negative strand. So during replication process inside the human host, what will happen? The nucleoprotein of the viral bind to the genome, and while M protein is associated with the membrane of the endoplasmic reticulum. So further, with the help of nucleoprotein, the RNA get assembled into a helical twisted structure and endoplasmic reticulum lumen. So virus progenies are transferred to the cell membrane by Golgi bodies and exocytosis into the extracellular spaces of the human cell environment. So the effect you see here, the COVID-19, when it entered into biological system of the human, it bind with the angiotensin enzyme, and that after the binding, it will fuse with the enzyme, and after the fusion, translation of the virus happen by the translation replication, and finally the COVID-19 protein, they form the their structure, and they attach with the open reading frames with the proteins of the biological system of the alveolus, and then inflammation happen in your lungs, and finally respiratory distress causes and cardio injury happen. So from the replication process of the SARS-CoV, it is clear that targeting NSP protein, because it play a very important role to replicate the virus inside the biological system, could be enable us to develop a strategy to overcome this virus infection, means the kind of drug who stop the replication of NSP protein. Other than replication, other pathways associated with the virus can also be targeted for the drug developments. So entry of the human coronavirus in central nervous system also, because the infection caused by the nostril, eyes and something, olfactory bulb, so nostril infection which cause the inflammation and demyelination in the central nervous system. So I can explain with the figure here. You see the COVID-19 also affect the central nervous system through olfactory bulb, and when it's injured, so how we get the information through cerebrospinal fluids, and we are going to the doctors test it, you know, it's affect brain also. So how the COVID-19 infected the nerve cells, and through that, so this is also one of the mechanism to develop a kind of drugs which are affecting the brain-blood barrier and stop the replication of the virus inside the olfactory bulbs also. So here we are going to talk, after the structure of the coronavirus, we are going to talk about the modern medicine and how the modern medicine are developing. So you see the vast variety of drugs used for the treatments worldwide fall under any of the following classification of the drugs: antiviral drugs, and how the antiviral drugs working. So that drug under this category follow either of the following mechanism: viral replication inhibition, ion channel, means calcium ion channel inhibition, serine protease inhibition. So commonly available antiviral drugs mostly target the four major groups of the viruses: HIV virus, herpes, hepatitis and influenza. Means these common drugs are available, and the doctors try to prevent these COVID-19 with the help of these common drugs. Even the anti-malarial drugs, so these drugs fall under the category based on their mode of action: aryl amino alcohol compound, and that is the antifolate compound and artemisinin. But disadvantage of this drug, that anti-malaria drugs having the resistance developed for the any drug under this category. So the doctors stop the anti-malarial drug. Now they are focusing the antiviral drugs. Those are available already in the market. So these drugs are classified into four different categories based on their target. So target, reverse transcription, retrotranscription, proteolytic processing, viral cell fusion, co-receptor interaction, and incorporation of the protease DNA into the host genome. So anti-HIV drugs, that's why also it's helpful. Now anti-inflammatory drugs the doctors are utilizing, because when the huge inflammation response is observed in case of COVID-19. So anti-inflammatory drug, especially JAK stat, that is an inhibitor used against rheumatoid arthritis. So doctor used this drug in the case of COVID-19 because in COVID-19, the inflammation happen after the infection. So according to recent study, an inflammatory drug, baricitinib, when used in the combination of the antiviral drug like remdesivir, increase the potential of the drug to reduce the viral infection. Now monoclonal antibodies also. So when the virus is known to enter the host cell by the inhibiting the S protein to angiotensin enzyme receptor, so they're developing neutralizing antibodies against the receptor. There is a high possibility for reducing the severity of the disease. So now the clinically used drug, the doctors are using to prevent the COVID-19. A list of drugs is tried by the different countries for COVID-19, but some commonly used drugs are ribavirin. This antiviral drug is used to treatment of hepatitis C, but they are utilizing in the COVID-19. Sofosbuvir, the act as a nucleotide polymerase inhibitor used for the treatment of hepatitis C, and this drug previously used in the treatment of the Zika viruses. Lopinavir, ritonavir, these drugs, it's a target provided inhibitor with the HIVs. So this drug prevents the formation of the viral protein by disrupting the proteolytic process, mimicking its structure as a peptide cleavage. And this drug, along with the other flu drugs, oseltamivir, was reported to result in the complete recovery sign of the COVID-19 related pneumonia. Remdesivir, this is the antiviral peptide. So this particular drug is an adenosine nucleoside analog. It was used in the treatment for the Ebola virus, SARS-CoV and MERS-CoV. So it is a promising and potential drug which cause premature termination by entering the nascent viral RNA. Now, a recent study has shown that remdesivir acts against COVID-19 and block the viral infection. Chloroquine also, this drug classifies as anti-malarial drug, has shown potential treatment of avian influenza. So chloroquine also has shown to have antiviral as well as immune modulating property. And this drug showed activity against COVID-19 and blocked viral infection by increasing the endosomal pH required by the viral infection. Now, the favipiravir, this drug is also a broad spectrum antiviral drug which has obtained approved from Shenzhen Health Commission for treating COVID-19 patients. So in China, they are utilizing this drug to COVID-19. Ongoing clinical trials, currently numerous companies that have applied for clinical trial to produce existing drugs as well to develop the vaccine. So now we have the vaccine in the market, Covishield and Covaxin from India and others from the US. So after the modern medicine, because modern medicine provides the symptomatic treatment, and also we have now the vaccine, but that is not a proper treatment. So the people are looking the herbs, and we are going to talk about Indian plants and effect in the COVID-19. So medicinal plants are considered as a rich source of ingredients which can be used in drug development, pharmacopoeia, non-pharmacopoeia, or synthetic drug, and play a major source of medicine for humankind. So at least 35,000 plant species are widely used for the medicinal purposes. And also WHO pointed out that traditional medicine provide an important role in the health goal. So we are going to talk about the India. So India has a rich tradition of the herbal medicine. In Ayurveda, more than 700 herbal drugs have been prescribed for the different kind of diseases. So some of them having the antiviral property. So for this purpose, medicinal plants and their bioactive constituents come in the center of interest. So because in developing countries, most of the population utilize the herbal medicine and they cannot afford the expensive chemical drug of prescribed medicine. So here we are going to discuss some of the important medicine of the Indian they are using in a common. For example, you see turmeric. Turmeric having the strong antiviral property, and curcumin is the main gradient, and curcumin is an anti-inflammatory property. Curcumin may protect against heart diseases. Curcumin may help ease symptom of osteoarthritis and also treat the diabetes. So you see the in India, every houses they are using the turmeric, having the strong anti-inflammatory, antiviral property. So these are the Indian herbs. Now the second is ginger. You see, also experiment proved that ginger have the antiviral property, and in ginger, the gingernol, this is the main constituent. It can support your immune system. It can reduce your risk of diabetes. It may lower your risk of cancer, and it is also an inflammatory drug. Now, the second herbs, you see the garlic, every houses they are using. The main constituent is allicin, and it's a proof that proteolytic and hemoagglutinating activity and stop viral replication. So garlic have the very important role. Also, it stop cold and flu, antibacterial and antiparasitic, prevention of heart disease, and also it prevent the role to prevention in cancer. Now we are going to talk about the onion. Onion also have the strong antiviral property. The main constituent is the quercetin. Also, it's proved that onion cancer prevention, blood pressure moderator, and skin and hair curing property. Now, the very important things, chili, because most every Indian houses they are using the chili, and its experiment proved that chili have the strong antiviral property. So quercetin is the main constituent. So chili pepper may have anti-cancer property. Chili pepper may have anti-inflammatory property, but don't take more. Chili also cause a problem. Now this is very important herbal medicine called megha. Kal megha is a plant which is also known as the green chiraika. It's a bitter, king of bitters, and main constituencies endographolites. So endographolites in Kal megha has antiviral and anti-inflammatory property. It inhibits the replication of the influenza virus. It also decreases the activity of inflammatory mediators responsible for inflammation of the lungs. So new researches, it shows that this Kal megha have a role in the COVID-19. It has antioxidant, anti-inflammatory, hepatoprotective property. It prevents the damage of liver cells caused by the free radicals. It might also be effective against the chronic hepatitis B viral infection also. So Kal megha is very important. Now we are talking about the tulsi, oshimum, and we are every houses. So a herb for all reasons. And main constituencies eugenol and alpha furcinol. So the every house is the tulsi. Now this is kunje. So this kunje, now it's experimentally proved that it's have action, inhibitory action toward the human coronavirus NL63, means that is the alpha coronavirus. So human coronavirus NL63. So kunj also utilizes by the heart. Those who are treating the heart by COVID-19. So it's very important property. Spinaches we have in houses. Spinaches and cabbages also have the antiviral property, and camphorol is the main constituents of these spinaches. Green tea, strong antiviral property. A main constituencies catsein and epicatsein. So it's advisable also you are taking the green tea in the every morning. Now the dedima. Dedima means anar. We are talking about Punica granuta. This dedima also have the very strong antiviral property, and punicalgin is the main constituents of in dedima. So according on the basis of what we discussed the herbs, so we are preparation of the herbal tea to check the COVID-19 as the initial prevention measure against the COVID-19. So we can prepare herbal tea at our home day by combination of the bashak that leaf having the anti cough and antiviral property, tulsi, pipli, green tail, and ginger means sunthi ribon. So this is my recommendations on the basis of literature survey. Even we are going to prepare the herbal tea with the help of these gradients, so we can boost our immunity and protect this pandemic COVID-19. So there is a literature also shows that Ayurvedic treatment of the COVID-19 SARS-CoV. The one paper I read, Journal of Ayurveda and Integrated Medicine, P.L. Girja and Arthur Sivan, they suggested Sudarshan Churn, Talisabi Churn, and Dhanvantara Gutika is very effective in treatment of the COVID-19. They have the data also. Now we see the drug Coronil approved by our government. So also this is useful in the treatment. This is the one of the medicine claim that this is effective in the COVID-19 treatment. So here what I want to say that what we are going to overcome with, there is no medicine in this world to treat the COVID-19. That's why we are having the vaccination. But we can use this medicinal plants, what we discussed previously, to boost our immunity and prevent against not only COVID-19, different kind of diseases also. So we are going to follow the guidelines, what about the governments to follow the wearing the mask and washing the hand. That is the main things to prevent with the COVID-19. So thank you for the listening of this lecture.
Thank you so much, sir. It was a wonderful lecture in which you told us that how Ayurvedic treatment can be done to reduce the effect of this coronavirus. Thank you so much, sir, for this useful lecture. Once again, thank you so much for being us with this lecture to our webinar. So our next keynote speaker for today's session is Professor Indra Prasad Tripathi. He is the Dean and former Pro Vice Chancellor at Mahatma Gandhi Chitrakoot Gramoday Vishwavidyalaya, Satna. I would like to invite and welcome Professor I.P. Tripathi, sir. Over to Professor Tripathi. त्रिपाठी सर, यस सर, जी सर आ रही है।
चलिए सभी को नमस्कार। मेरा बहुत कुछ ऐसी बैठक थी जिस कारण से मैं जोड़ नहीं पाया, सबको सुन नहीं पाया। बहुत अच्छे लेक्चर चले और कुछ विषयों पर मैं बातचीत करूंगा। बहुत विषय आपके हो गए हैं, लगभग मैंने सारे विषय देखे थे। अच्छा कार्यक्रम था और मैं नहीं जुड़ पाया, इसके लिए मैं क्षमा भी चाहता हूँ। मैंने एक विषय दिया था आज के लिए कि रसायन विज्ञान आज और कल। अभी बीबीएल श्रीवास्तव जी का लेक्चर हम लोग सुन रहे थे, किस प्रकार से उन्होंने कोविड-19 की समस्या और हमारी जो मेडिसिनल प्लांट्स है, भारतीय औषधियां हैं, ये किस प्रकार से इम्यूनिटी डेवलप करते हैं। इन सब विषयों पे हमारे जो नेचुरल मटेरियल्स है, नेचुरल केमिस्ट्री जो है, उसके विषय में बहुत सारा विषय बताया। एक विषय आता है कि केमिस्ट्री क्या, तो केमिस्ट्री का आज क्या चल रहा है, टुडे क्या केमिस्ट्री चल रही है। तो मोस्टली जो स्टूडेंट है, हालांकि आज की डेट में केमिस्ट्री तो पढ़ना चाहता है, और लेकिन अगर हम स्टूडेंट के पॉइंट ऑफ व्यू से जाएं कि उनका मैक्सिमम हम स्टूडेंट को देखें तो केमिस्ट्री के विषय में क्या सोचते हैं, तो वो सब सोचते हैं कि ये बहुत बोरिंग विषय है, बहुत ज़्यादा रिलेवेंट विषय नहीं है, बहुत डिफिकल्ट विषय है और अच्छे ग्रेड्स नहीं मिल पाते केमिस्ट्री पढ़ने से। और उन सब का कारण है कि करेक्ट जो है एडवाइस नहीं मिल पाती, उनको सही सलाह नहीं मिल पाती, जिससे कि ये स्टूडेंट के मन में बहुत सारी केमिस्ट्री के प्रति जो है भावनाएं चलती रहती हैं कि किस प्रकार से इसको लेकर के आगे करियर में जाएंगे। जबकि अभी हम देख ही रहे थे श्रीवास्तव जी के लेक्चर में और इससे पहले भी लेक्चर हुए होंगे कि किस प्रकार से हर जगह पे केमिस्ट्री इन्वॉल्व है। बिना केमिस्ट्री के तो कुछ चल नहीं पा रहा है, लेकिन प्रॉपर केमिस्ट्री के बारे में जानकारी न मिल पाना ये एक जो है बड़ा कारण बना हुआ है। अगर हम टीचर्स के व्यूज देखें कि केमिस्ट्री के बारे में क्या है, तो जनरली ये आता है कि केमिकल्स नहीं मिल पा रहे हैं, इक्विपमेंट की कमी आ रही है, फैसिलिटीज नहीं मिल पा रही हैं, ये बहुत ज्यादा एक्सपेंसिव हैं, मिल नहीं पा रहे हैं। ये एक टीचर्स की प्रॉब्लम्स रहती है। दूसरा, उनको लगता है कि केमिस्ट्री का कोर्स भी डिफिकल्ट महसूस होता है, टीचर्स की भी ये प्रॉब्लम है। केमिस्ट्री में अगर चलते हैं तो मोस्टली जो है टीचर्स के अंदर भी सेफ्टी की, एश्योरेंस की और खासकर बेस्ट डिस्पोजल की दुर्भावना बनी रहती है। जैसे रेडियो एक्टिव मटेरियल्स है, इनके जो काम करने के बाद में निकलते हैं, इन सब पे उनके मन में बनी रहती है, डिफिकल्टीज बनी रहती है। और लगता है कि हमारे जो है वो स्कूल लेवल में बच्चों को भी जो लगता है, उन्हें भी लगता है कि जैसे हमारे बच्चों को ग्रेडिंग कम मिल पा रही है, नंबर कम मिल पा रहे हैं। इस प्रकार से जो है स्कूल टीचर्स की ओपिनियन बनी रहती है। अगर हम देखें कि पब्लिक की और जो मास मीडिया है उसकी क्या ओपिनियन केमिस्ट्री के बारे में है, तो वो केमिस्ट्री, पहली बात तो केमिस्ट्री जानते ही नहीं है कि केमिस्ट्री क्या है, उसको अच्छे से समझ नहीं पाते हैं। और प्राय हम देखते हैं, चाहे न्यूज़पेपर्स देते, मीडिया को देख लें या पब्लिक में देख लें, तो वो केमिस्ट्री में उनके केमिस्ट्री के प्रति उनकी जो है हमेशा ब्लेम्स करते रहते हैं, दुर्भावनाएं बनी रहती हैं कि इससे बहुत सारी आपदाएं आ जाती हैं, पोल्यूशन फैल रहा है, इन्वायरमेंट का डैमेज होता है केमिस्ट्री से, ग्लोबल वार्मिंग बढ़ रही है। वो केमिस्ट्री के तत्व देख लेते हैं कि केमिस्ट्री है, तो उनको लगता है कि इस प्रकार से बहुत सारे जो है दिक्कतें केमिस्ट्री के कारण आ रही हैं। गवर्नमेंट की भी क्या ओपिनियन है? गवर्नमेंट की ओपिनियन है कि ये गवर्नमेंट केमिस्ट्री के बारे में समझ रही है कि केमिस्ट्री किस प्रकार से, बिना केमिस्ट्री के हमारी इंडस्ट्री नहीं चल सकती है, हमारे देश का स्वास्थ्य नहीं सुधर सकता अगर हमारी केमिस्ट्री ठीक नहीं है, केमिस्ट्री पे अच्छा काम नहीं हो रहा है, केमिस्ट्री लोग नहीं पढ़ रहे हैं, जो है रसायन के बिना जो है। तो ये गवर्नमेंट इसको समझ रही है, वो दिन रात चाहती है कि नए नए इनोवेशंस आए इस क्षेत्र में। तो इस प्रकार से गवर्नमेंट की और हर कंट्री की नीड रहती है कि वो अच्छे जो है मेडिसिन आए और उनका जो है हम उपयोग कर सके। अन्य जैसे इस प्रकार कोविड आई, तो कोविड भी जो है हमारे रसायन से है, जो महामारी आई, विश्वव्यापी आपदा आई, इसमें भी हमारे जितने भी हमारे बूस्टर्स लगे सब कहीं न कहीं केमिस्ट्री से ही उसकी उत्पत्ति है, बिना केमिस्ट्री के आगे नहीं चल सकता है। तो इस प्रकार से केमिस्ट्री की किस प्रकार उपयोगिता है, क्या केमिस्ट्री के प्रति लोगों की धारणा है, इन सब चीजों को हमें देखना पड़ेगा। और अगर केमिस्ट्री के हम भविष्य कल की बात करें कि केमिस्ट्री से तो हमें करना क्या चाहिए, तो आजकल हम देखते हैं प्राय स्टूडेंट क्या चाहता है कि एकदम वो तुरंत मल्टीमीडिया और आईटी की ओर बढ़ता है। इसमें भी हमारी जो हाईटेक सोल्यूशन में भी केमिस्ट्री इन्वॉल्व है, चाहे वो आप नैनो चिप्स बनाने हो, अंततः वो केमिस्ट्री का ही प्रोडक्ट है, लेकिन लोगों के समझ में नहीं आता। छात्र को लगता है कि नहीं ये सब चीजें हैं, हम उसको उसकी केमिस्ट्री नहीं बता पाते हैं। जबकि केमिस्ट्री कल जो भविष्य जो है केमिस्ट्री से ही है कि जितनी भी मल्टीमीडिया का है, आप चाहे लो टेक्नोलॉजी के करें, लो कास्ट टेक्नोलॉजी की बात करें, प्लास्टिक हो गए, ये सब हो गए, इन सब चीजों में जो है बिना केमिस्ट्री के आगे बढ़ नहीं सकते हैं। तो बहुत सारे आजकल जितने आ रहे हैं इक्विपमेंट्स आ रहे हैं, उनका वेट कम करने के लिए या कहीं कोई उसमें हाई स्पीड करने के लिए जो है केमिस्ट्री ही उसमें नैनो टेक्निक्स जितनी है, नैनो कंपोजिट्स बना करके ही कर सकते हैं। तो इस प्रकार से हमें जो है केमिस्ट्री के कल के विषय में सोचते हुए छात्रों के बीच में ले जाना पड़ेगा, इसको देखना पड़ेगा कि किस प्रकार से हम इसको छात्रों में इसकी केमिस्ट्री के प्रति रुचि पैदा कर सकते हैं और वास्तविकता उसको बता सकते हैं। आज जो विज्ञान का दिन है, विज्ञान का युग है, इसमें बिना केमिस्ट्री के आगे नहीं बढ़ सकते हैं। चाहे वो कोई मार्केट के अंदर हो, सुपरमार्केट्स हो या इन्वायरमेंट की हो, बिना केमिस्ट्री को जाने हुए, बिना केमिस्ट्री को साथ लिए हुए आगे बढ़ नहीं सकते हैं। क्योंकि हम सब जानते हैं कि केमिस्ट्री के बिना जो है, चाहे वो मेडिसिन का क्षेत्र हो, चाहे हमारे इक्विपमेंट्स हो, चाहे हमारी सुख सुविधाएं हो, उन सबको केमिस्ट्री को लेकर के चलना पड़ेगा। हाँ, यह बात सही है कि हमको उस केमिस्ट्री के जो दुरुपयोग होते हैं या जिसको लोग समझते हैं कि इससे केमिस्ट्री बहुत कठिनाई आ रही है, उन चीजों को भी ध्यान रखना पड़ेगा कि हमारे जो प्रोडक्ट्स हैं वो बाई प्रोडक्ट्स इस प्रकार के न बने जो कि हानिकारक हों। उनके वेस्ट डिस्पोजल का अगर हम कोई इंडस्ट्री, केमिकल इंडस्ट्रीज लगा रहे हैं केमिकल बेस्ड, तो उसके जो है उनके हमको देखना पड़ेगा कि उनकी डिस्पोजल ठीक से हो सके, वेस्ट का मैनेजमेंट सही ढंग से हो सके। ये सब विषयों को लेकर अगर छात्रों के अंदर बताएंगे तो जो केमिस्ट्री के अंदर एक भय बना हुआ है, उस भय को हम खत्म कर सकते हैं, तो केमिस्ट्री आगे चल सकती है। तो ये संक्षेप में मैंने थोड़ा केमिस्ट्री के विषय में रखा, और अब बाकी विषय विस्तृत रूप से चले हैं। मैं आयोजकों को बहुत बहुत धन्यवाद दूंगा कि उन्होंने मुझे इसमें जोड़ा, और मैं क्षमा भी चाहूंगा, कुछ मेरी अपनी व्यक्तिगत कुछ बैठक है, मैडम से बात हुई थी अभी, तो उन्होंने कहा नहीं 10 मिनट के लिए जुड़ जाइए, मेरी अभी एक बैठक है तो उसमें जाना पड़ेगा, 2:30 बजे से है, और मैं अपनी बात को पूरी करता हूँ। धन्यवाद मैडम।
थैंक यू सो मच सर। थैंक यू सर। धन्यवाद सर आपका बहुत बहुत कि आपने हमारे इस वेबिनार के लिए अपना कीमती समय निकाला। थैंक यू सो मच। Due to some technical reasons, we are not able to connect to Dr. D.V. Prabhu sir. So he will join us through his lecture in our next webinar. So taking this session further, I would like to invite our Dean Faculty of Basic Science at A.K.S. University to address us all for the concluding remarks on behalf of A.K.S. University. May I request Professor R.N. Tripathi sir. Over to Tripathi sir.
Thank you, madam. Respected keynote speakers, dear faculty members, research scholars, and students. It was a great moment for A.K.S. University and Govt.Girls College Satna to organize this seminar. Actually, when our basic science department chemistry thought of to organize this webinar, Dr. Shailendra Yadav proposed this, and incidentally Mr. Manoj Sharma, one of our faculty member of chemistry department, who has done his research, was under Dr. Neelam Vicharia, principal, Govt. Girls College, was also present, and he discussed with Dr. Vicharia that university is also going to organize one webinar. It was a coincidence that Dr. Neelam Vicharia was also going to organize such webinar, and it was a proud moment for both of the institutions, that is A.K.S. University and Govt. P.G. Girls College Satna, that we approached together to organize this seminar and decided to do this event. When we approached our chairman, Engineer Soni, as his nature, he promised very humbly to provide all the administrative assistance, not only administrative, but financial assistance also. Hence, this seminar was organized, especially efforts of Dr. Neelam Vicharia, who is principal, who was a professor there. He is a chemist. She is a chemistry scholar and doing great work as an academician, as an administrator. Because at present, the Govt. Girls College has got nearly 80,000 girls with different streams and courses, and it is rather very difficult to run this college with lack of staff, lack of infrastructure. But Dr. Neelam Vicharia, with her efforts, is continuously and constantly maintaining high standards of academics and discipline and we are proud to say that the Girls College, Government Indira Girls College, is not less than any model college of Madhya Pradesh. So we are very pleased to announce this, that we both contacted the scientist and we were lucky that all of them have given their kind consent. Such great scientists have given their kind consent, which is very crystal clear message to our students, to our research scholar, to our faculty members, teachers, that all these keynote speakers who are great scientists has got the love for their subject, chemistry, and they are dedicated for the promotion of their subject. And we are thankful to them to spare valuable time, spare their valuable moments, and they have taken the trouble to address this webinar, by which so many research scholars and students were ignited to go for research, to go for study of the subject of the chemistry. Actually, these scientists are working in a very dedicated and committed manner for the welfare of the human race and for the sustainable progress of the world by protecting nature and environment. Particularly, organizing committee would like to mention the name of Honorable Dr. Prabhu, who is at University of Mumbai, Wilson College. He is very senior professor and guide as far as the chemistry subject is concerned. Dr. Qureshi from Saudi Arabia, Dr. Shyam Pandey from Japan, Dr. Amrish Singh, Dr. M.L. Sharma from Nepal, Dr. B.B.L. Srivastav from Tanzania. These all 5 foreign scientists and chemistry professors were very kind enough to give their valuable lectures, and this indicates that they have got the love for their soil, that is for their nation India. We all salute for their spirit, for their love, for their dedication towards our nationhood. We are also thankful to Dr. Mrs. Sanadhan Singh, Professor IIT BHU, Professor Indrajit Sinha, BHU, Dr. Vijay Agrawal, A.K.S.University, and Dr. I.P. Tripathi from Chitrakoot University, because they all are having their previous assignments, and in between these assignments, they have also taken trouble to spare their time. The organizing committee also very thankful to them. We also thank to all the students, to all the research scholars who were associated in this webinar for 2 days. Definitely, we are also thankful to our all faculty members who has cooperated with us to make this webinar successful. Our IT department of A.K.S.University, which is very updated, and I think it is not less than any Indian university as its merit is concerned. So we are also thankful to the IT department personnel who are day and night busy with us in cooperation to the seminar. I hope that this webinar is successful, and in future, when we organize such webinar, all our dignitaries who have participated, who have given their valuable time and deliberations, will be kind enough again to give their valuable time, their suggestions, their cooperations, their guidance to the A.K.S.University and to the Girls College Satna. So I thank all of you for this cooperation and for your successful time giving. Thank you very much. Over to Lovely, ma'am.
Thank you so much, sir. And we are able to do this under your kind guidance. Your skills of excellency always enlighten us whatever we do. Thank you so much, Tripathi, sir. Lastly, once again, I would like to thank each one of our keynote speakers who graced our program through their profound and deepest knowledge and sharing their rich research experience today with us. We also thank the IT department of A.K.S. University for extending their support for this webinar. Last but not the least, we are much grateful to Dr. Neelam Richaria, Principal at Govt.Girls P.G College, Satna. And I, Lovely Singh, take it a great pleasure on behalf of entire A.K.S. University and organizing team. Once again, thank you all for being here with us and officially announces the closing of 2 days international webinar on recent contributions of chemical science to modern society. We look forward with the next webinar to have your presence once more and for the future events. With all these words, I, Lovely Singh, once again, thank you all for being here with us for 2 days. Thank you and namaskar.